Databricks is quickly becoming the default data and AI platform for modern companies. It is valued at around $134 billion, and behind those numbers is a simple story. Instead of stitching together separate tools for data engineering, warehousing, machine learning, BI, Databricks gives you one unified data intelligence platform where all of this lives together, right? So that is why several organizations, including a huge chunk of the Fortune 500, are standardizing on Databricks, right? To basically be able to power everything from analytics, reporting, AI agents, and LLM powered apps. So, as an engineer, what advantage do I have, right? That simply means that if you can build real solutions on top of Databricks, you are instantly more valuable in the job market. So, in this project that we are building together, by the end of it, I want you to be able to say very confidently that I have built an end to end restaurant analytics platform on Databricks. Streaming, batch, AI, dashboard, everything end to end. So let's get into the details. What are we going to build together? We are going to model a large Indian restaurant chain operating across 5 different locations in the UAE with 500 customers, thousands of reviews and orders. So this is how the complete architecture is going to look like. You are going to work with two real data sources. Number one is Azure SQL databases for customer, restaurants, menus, historical orders, and reviews. And then Azure Event Hub for real time streaming orders, mimicking a live POS system, sending new orders every few seconds. So inside of Databricks, we will set up a full lake house with Unity catalog and a Medallion architecture, landing bronze, silver, and gold layers. We are going to use LakeFlow Connect to do the change data capture ingestion from SQL Server into the bronze and the silver layer. So the inserts and the updates in the source, which is SQL Server in this case, flow automatically into Databricks without having to write custom code, right? So that's the beauty of it. You don't need to write any custom code. And then we'll be using another interesting feature of Databricks, which is Spark Declarative Pipelines to stream real-time orders from Event Hub into the bronze layer, right? So this is going to mimic a real-time POS system. And finally, we are going to combine these real-time orders with a one-time historical load so that our downstream analytics, the dashboard that we build, they see the full picture. Yeah. So from there, we are going to transform raw data into a very powerful data model using the star schema. We are going to build fact orders for order level analysis, fact order items where we are going to explode all of the items in an order into different rows so that we can see item level performance, and then finally a fact reviews table. And here is where the interesting part comes in. For reviews, we are going to use AI query and models from Mosaic AI to run sentiment analysis, and that to directly in SQL, right? Directly in SQL. So you're going to understand sentiment, categorize issues from customer reviews. And then finally, on top of that, we are going to create the gold layer for daily summaries, customer 360 profiles, and restaurant level review metrics. So finally, you're going to build two production style dashboard. The first one is a chain performance dashboard. So if you're the owner of a restaurant, you would want to see how things are behaving at an overall chain level, right? And that is exactly what this dashboard is for. And then finally, a review inside dashboard to track the sentiments, trends, issues, and recent feedback. So all of this stays inside Databricks, your data, AI, and BI on one platform. By the end of this video, you will be able to clearly explain a complete architecture. So Event Hub plus SQL as sources, LakeFlow Connect and streaming pipeline for ingestion, Medallion layers in Unity catalog, AI in your transformation, workflows for orchestration, and dashboard for consumption. exactly how real teams are building on Databricks today. So this project is designed to help you build real skills for your interviews and day-to-day job. So one last thing before we get started, throughout the series you'll see something I call the concept vault. Anytime we hit an important Databricks feature, let's say Spark Declarative Pipelines or Unity Catalog, we are going to pause and go deep on that concept. And you don't need prior experience. It's completely okay if you haven't heard about that feature or if you haven't worked with that feature. We will build that knowledge together and store it in your mental vault so you can confidently explain these topics in interviews or in real world discussion. Yeah, so stay with me until the end of this video, and now let's start building. So firstly, let me walk you through the data set that we are going to use for this project, and most importantly, how do we create that synthetic data, right? So to let you know, this is for a large Indian restaurant chain based across 5 locations in the UAE, and 2 are based in Abu Dhabi, 2 are based in Dubai, and 1 is based in Sharjah, right? So here are the different data sets that we are going to create. Number one is your customers, and they have around 500 registered customers. Restaurant based across different locations in the UAE, and then you have menu items for each of the different restaurants. Historical orders, basically those orders which have been placed in the last 6 months. So we are going to import this data into our orders table in Databricks, right? So this is the last 6 months of orders. And then finally you have reviews from customers, which contains your ratings and the review text that is given by the customer. Yeah. So I've put all of the data that you need for the project in this synthetic data slash data folder, and you will also find this on GitHub. So if you click on the Databricks project, synthetic data, these are the CSV files that you can readily use without having to run any of the synthetic data generation scripts, right? But if you are interested in understanding how the synthetic data set was created, here you have all of the piece of codes, right? The first one is SQL underscore db.py, which basically shows how your restaurant data was generated, which is over here. And then you have a set of mouth-watering Indian food items, which is generated as a part of your menu items. And then finally, you have your customers, and then we save all of this into CSV files, and this is saved in the data directory, right? And then you have your historical orders, and if you remember, we just spoke about this. These are orders which were generated in the last 6 months, right? And we read restaurant customers and menu items that we have just generated so that the orders look realistic, right? The order is coming from a restaurant or a customer who exists in my database, right? And then we generate these historical orders, and this is basically saved in the data folder again. And finally you have your reviews, where these are some templates that we've used for a 5-star rating, for a 4-star rating, and so on, right? And again, these are generated with this kind of a format where you have your review ID, order ID, the customer who gave the review, what is the review text, and what is the rating, right? And then this is finally saved to customer reviews. Yeah, now understand that not all orders are going to have reviews, and that is why we have set a percentage over here which decides the number of orders that is going to be having reviews, and those are the orders which is going to be saved in this CSV file. Yeah, and finally we've created a script which is going to generate all of the data sets that we just talked about, right? So now we want to run the script. What we do is I just run python synthetic data.py, and we run this, and it is going to generate all of the orders, right? So I already had this, but it must have overwritten it with new data, right? So that is how you can generate synthetic data for this project. So now we'll be setting up our real-time data source, and by the end of this part, you will have orders streaming into Event Hub, ready to be consumed by Databricks, right? So first of all, we need an Event Hub namespace, right? And you can think of it as a container for our Event Hub, similar to how a Kafka cluster contains topics, right? So let's go to Event Hub. Let's create an Event Hub namespace. And I'm going to create a new resource group. The reason for creating a new resource group is so that all of the resources that we create in the project, they remain confined to this resource group, right? And let's name this as eh-namespace-dbx project, right? For this one, because we are assuming that the restaurant chain is based in the UAE and the development is also going on in the UAE, we are going to select UAE North, and I am going to select a standard pricing tier. The reason why I'm not selecting a basic pricing tier is because I want something known as Kafka Surface to be enabled, right? And what exactly is Kafka Surface? Kafka Surface in Event Hub basically refers to the built-in support it has for the Apache Kafka protocol, right? So what does it do? It allows user to treat Event Hub as a Kafka topic, right? Very interesting. It allows Event Hub to be treated as a Kafka topic without having to manage your Kafka brokers, right? So what that means for me is that Event Hub is going to provide me an endpoint which is compatible with Apache Kafka, and I can use it, right? I can use it with the structured streaming Kafka connector, right? I can use that endpoint to be able to read all of the data from that topic or Event Hub. Yeah. So let's quickly go ahead and click review and create. Okay, so now the Event Hub namespace is deployed, and we are going to create an Event Hub inside this. And I'm going to name this orders, right? Because all our streaming orders is going to be coming into this Kafka topic, right? All of the other things are correct. And let's go ahead and click and review and create. Great. Now the Event Hub has been created over here. Now, a very important thing that we need to do is we need to create two policies, right? Two policies. And let me quickly explain what exactly are these two policies. So basically, we have Event Hub over here, right? Event Hub. Let me zoom in a little bit. We have Event Hub. Now, there is going to be a producer who is going to produce these orders, and they are going to send this data to Event Hub, right? It's going to send all these orders to Event Hub. Now Event Hub is going to say, who are you, right? Why should I accept orders or whatever record that you are sending to me, right? Then this guy, this producer, is going to have a connection string, right? It is going to have a connection string using which it is going to make a connection to Event Hub. It is going to show this connection string saying that, okay, you are the one who has given me permission to be able to push data to Event Hub, right? And similarly, Databricks is going to be the one, Databricks is going to be the one which is going to read data from Event Hub, right? Similarly, Event Hub is again going to say that why am I going to allow you to read data from myself, right? Then Databricks is going to again show a connection string, right? Connection string saying that, okay, you are the one who gave me permission to be able to read data from this topic or from this Event Hub, right? So that is why we need to create number one, the send policy, and number two, the listen policy. Yeah. So let's go ahead and create the send policy first. Producer send policy. And when I click on this, right, you would see a connection string, right? So this is the connection string that the producer would be using when sending data to Event Hub, right? Let me also create another policy, which is going to be Databricks read policy. And I'm going to click on listen over here. Now, when Databricks is going to read data from Event Hub, it is going to use this connection string, right? To be able to read data without any permission issues from Event Hub. So now that our Event Hub is set up, let's quickly have a look at our order generator. And you would see that this piece of the code, right, where we are taking up the same restaurant, customers, and menu items for the order to look realistic, this part of the script is just the same as historical order generation, right? This part of the script, right? So instead of saving the orders, what we are doing right now is we are using the Event Hub producer client, right? And you see that we have the Event Hub connection string over here, which will be taken from the Databricks, sorry, not Databricks, but the producer send policy from here, right? So what you need to do is set up your local environment. I use Conda, and then I would create a Conda environment and I would install all of the requirements that we've listed over here. Sorry, this is the set of requirements that we've listed over here, and I would run this script, right? So now we simply need to take this primary connection string over here, put it in a .env file. Now this would be a best practice. You can of course also directly put it over here, but I would not recommend that. And then we take up the Event Hub name, right? So this is our Event Hub name. We go to overview, we go over here, and this is going to be orders. Let me simply replace this with orders, and this is going to be the connection string. Yep, so this is done. Now we simply create a batch, right? In a batch, I am simply going to attach one order. We can attach more than one order, but I'm going to attach one order for simplicity. And of course, we don't want to incur a lot of Event Hub cost, right? Uh, and finally, we send this batch through the producer to Event Hub, right? Now let's go ahead and run this script. Okay, so we see that it has started to stream orders into Event Hub, and it is going to do so at an interval of these many seconds, right? And this is 3 seconds, right? So every 3 seconds, I'm going to send a new order. Now let's quickly validate this. We go to Data Explorer, and let me select the newest position. And here you see that these are some of the records, right? um, these are exactly the same format. And for example, let me see this one, right? Let's see this one, order ID, and this is the same order ID that was sent from our producer, right? So this is now our live data source in a real scenario. This would be your POS system, your mobile app, or a web application pushing order events, right? So we'll keep this script running as and when needed when we start consuming our data in Databricks. But the good news is that we've set up the streaming data source in Event Hub. Yeah. So now we are setting up our second data source, which is the Azure SQL database. And this is going to have data for your customers, restaurants, menu items, historical orders, and reviews. Yeah. So let's go ahead and create this, and we are going to select the same old resource group. Let's name this database as restaurant ops. Let's create a new server, and this is going to be SQL Server ops, and I'm going to place this in the same region. Let's use SQL authentication, and let's use this one now, and this is going to be the password. Of course, not the best password in the world, but let's use this for now. Yeah. And the workload environment is going to be development. Let's have a look at the compute and the storage types, right? Um, this one is compute cost per month, vCore. Sorry, this is not per month. This is vCore per vCore second, compute cost per vCore second, and this is the storage cost per month. This is basic is 6.46 USD. But let's go ahead with this one, which is general purpose and serverless. If you're careful about the resources being used on the project, right? And you turn it off the moment you complete the project, I am very sure that it is not going to incur you more than $2, $1 or $2, right? And let's select this to be locally redundant backup storage. We select public endpoint and we need to enable this to yes, yeah, add current client IP address. So when the SQL Server database is created, we want to upload data to it using Datagrip or any other client, right? So for Datagrip or our machine to be able to communicate with this database, you need to whitelist this IP address, our IP address, right? And that is what we are going to do over here. We select a yes, and then we also need to allow Azure services and resources to access this server. So Azure Databricks is another Azure resource. It should be able to access, it should be able to read data from SQL Server. So that is why we select this as yes, saying that the other Azure services should be able to access this server. Yeah. And then we click on next. All of this is okay. And then let's quickly go ahead and click on review and create. So now our restaurant ops database is ready. Now I'll be using Datagrip to upload synthetic data from local CSV files into the Azure SQL database. So here is my Datagrip interface. I mean, of course, you're free to use any other client, but Datagrip is something that I use quite frequently and it's very helpful. So I'll go to the data source Azure SQL database, and let's go ahead and copy all of these credentials. The restaurant ops, let's copy the SQL server name. This is going to be user and password. The username we selected was this one, and the password is going to be this one, and the database is restaurant ops, right? And let me also name this as restaurant ops. Let's go ahead and test the connection. Perfect, this works. Okay, so now I'm going to show you the script. You go inside SQL and then you see Azure SQL database setup, right? So these are the tables. We've referred to this a good number of times by now. We are going to first create all of these tables, and then we are going to enable CDC and change tracking on them, right? Using all of this code over here. Yeah. So let's go ahead and create all of these tables, and we are going to simply create it in the DBO schema over here, right? So this is the restaurant ops database, and this is the DBO schema, right? So let's go ahead and quickly do a schema name and replace it with DBO. Let's go ahead and run all of this now, right? So all of this is connected, and if I refresh this, I should see all of these tables. Perfect, right? Now let's go ahead and insert those CSV files, import these CSV files, right? So this is your customers. You're going to select customers. Okay, this mapping makes sense. Let's similarly do it for all the other files. Menu items now. Let's verify this quickly. So this one shows auto C1, C2. So for that, we need to go here. We select first row is a header, and then we come here. And then now let's see the mapping. So restaurant ID is correctly mapped, name is correctly mapped, right? Okay, now that all of the data is imported, let's quickly have a look at these tables. This looks fine. This also looks fine. So all of this looks fine, right? Let's do a sanity check by quickly counting the records. Select count star from DBO dot customers. It should be 500. Perfect. Historical orders. This should be 8,000, close to 8,000. Yeah. Okay. Then I believe all of this works properly and our synthetic data is now uploaded to the SQL Server database. One more important step, we need to enable change tracking and CDC. So we need to install a utility script, right? We need to install a utility script that I will show you, which is this one right over here, right? And you can find this script at this link, which I've already specified, right? So we need to install this utility script and enable change tracking, which is change tracking and CDC for SQL Server and for LakeFlow Connect, right? So let's go ahead and let's select this database and we go to SQL script, run SQL script, and then we go to SQL utility script. Let's go ahead and run this. Okay, this has completed successfully. Now we want to execute all of these statements, right? So let's copy all of this and let me paste it here. Yeah, so the database name is restaurant ops and all of this is going to be the same. This is going to be DBO customers, CDC enable. This basically executes a stored procedure, and we are also enabling change tracking for LakeFlow. Let us put our username and password over here, right? So now we can run this. Let's go ahead and run this. Okay, we see that change tracking is enabled already and the CDC is already created. Yeah, perfect. Excellent. So we now have both our data sources ready. Event Hub is streaming real-time orders and Azure SQL database is now set up for batch ingestion. Welcome to the concept world. We are going to uncover what Unity Catalog is. But if you are already comfortable with Unity Catalog, feel free to skip this section, right? So first things first, let's try to understand why did Unity Catalog even come into existence, right? What are the problems? What are the problems that Unity Catalog solved? Yeah. So the first problem that is solved was data sprawl. Now, what does data sprawl mean, right? So the understanding is that your data, the reality is that your data is spread across many different buckets, databases, and workspaces, right? So your data is spread across many different buckets, which is, for example, let's say S3, ADLS, many different databases and workspace. And this is the reality of many organizations in the world today, right? With no single trusted map of what data do we have and where exactly is it located, right? So this leads to uncontrolled growth of data across different locations and systems. Yeah. And you may ask why. The reason for that is if I don't know that this particular data already exists in my system, I'm going to create a pipeline, an ingestion pipeline, and ingest that data, right? That data may already be present somewhere, but I am unable to locate it because I don't have a single trusted view of it, right? So Unity Catalog's role is to pull all of this, right? Pull all of this into a single governed unified view of your tables, views, volumes, and models across all of your workspaces, right? And all of your locations. Problem number two is inconsistent access control. right? So different systems such as cloud storage, your databases and workspaces, right? Databases and workspaces, they basically have their own security model. The way you give permissions to each of these varies, right? So they're configured separately, so overlaps and gaps appear, right? So some users can see more data than they should, while others can bypass the controls entirely, right? So the role of Unity Catalog is to provide one consistent one consistent central role-based access control, right? So one consistent central role-based access control. So there should be one place where you can manage permissioning and access to all of these resources in your data system, right? Problem number three is your discovery challenges, right? So data scientists and analysts spend disproportionate amount of time just finding and understanding the right data set before they can do serious work, right? So Unity Catalog discovery layer, which provides you with search, tags, lineage, quality signals, is intended to improve the observability of your data and AI assets, right? So it is intended to improve the observability of your data and AI assets. And this basically includes your tables, volume, your AI assets would be your models, right? This is basically so that technical people can actually spend more time generating actual insights. Yeah. Problem number four is compliance challenges. So in order to simply get the answer to who used this dataset X in the last 90 days, people must manually stitch together logs from different systems and still not be sure whether that is the right answer. Yeah. So Unity Catalog automatically captures user level audit logs, right? So basically who access which system, with data set across different workspaces, and it places all of them in system tables, right? And we can basically query these system tables in order to understand who accessed which data set. We can also understand the costing of our compute operations or different operations that we've executed. Yeah. So we've seen that Unity Catalog solves all of these problems quite beautifully. And the goal of Unity Catalog is to provide a unified governance solution, right? The goal is to provide a unified governance solution, unified so that you can manage all of your data and AI assets in one place. Yeah. So let's understand the Unity Catalog object model. Yeah. Unity Catalog has a three-level namespace, right? And by three-level namespace, what I mean is that in order to access any of its objects, right, you need to do you need to go through the three-level naming convention, which is the table, and then the schema, and then the catalog, right? Now this table can be either a table or a view or a volume or a function, right? Now, a possible question, of course, you might have it: what exactly is this catalog, schema, and most importantly, what is the meta store, right? So the meta store is a top level container, right? So this is the top level container which is going to hold metadata for the Unity catalog, right? Now, when a workspace is created, when you create a Databricks workspace, Databricks automatically creates a meta store if it already does not exist in that region, right? So you're going to create your workspace in a region. That region should, if it already has a meta store, it is going to use that. If it doesn't have a meta store, it is going to create one, right? And this meta store, where is it going to store data? It is going to store data in, let's say if you're using Azure, it is going to store it in a storage account, or if AWS is being used, it is going to store it in S3. Now this is stored in the control plane. Basically what this means is Databricks stores it in its own storage account, you don't store it until you make some configuration, right? But the default is that Databricks is going to store the meta stores data, the metadata in its own storage account in the control plane, right? Now, below that, we are going to have catalogs, schemas, and table views, volumes, and functions. It's very important to note that one region can only have one meta store, right? And this is the rule that has been made by Databricks by default, right? One region can have one meta store, right? Now, let's understand what exactly a catalog and schema are. A catalog is the primary unit of data organization, right? And it also represents how you logically isolate data. So, for example, it can represent organizational units. So, let's say you have a supply chain unit, right? We have a supply, we have a supply chain or a marketing team, right? These are different departments of the same organization. Now, these may have different catalogs, and that is how these departments isolate their data. Or data can also be isolated in different software development life cycles, right? What I mean to say is that you can have a dev environment, you can have a staging environment, and you would have a prod environment, right? So similarly, you would have a dev catalog where you store all of the data sets, your tables, volume, functions, and views for the dev environment in one catalog. So there can be something like, let's say, marketing dev, and then you would have marketing staging and marketing prod, right? And similarly, you would have for, let's say, the supply chain. So basically, the naming convention or the structure that we are following here is BU, which is your business unit, and the software development life cycle, right? Or let me just name this as environment over here, right? And we can just name this as catalog, right? Now, schemas over here can be simply thought of as databases. And these databases are then going to have your tables, your views, volumes, and functions, right? So typically a schema represents a single use case or a project or a team sandbox, right? So if you have a marketing team, this can have, let's say, a project one, and then all of this table one, table two, similarly project two, right? Or let's say this can be another use case and so on, right? So I hope now metastore, catalog, and schemas make sense. Now it's time to set up Databricks. We are going to create a Databricks workspace, right? And this is going to be in the same resource group again. And let me create this as RG, sorry, not RG, but WS Workspace DBX project. And this is going to be premium. All of this should be okay. Let's go ahead and click on the create button, right? So this is going to provide us a Databricks workspace along with Unity catalog already configured, but we would need to create the schemas, which is the landing, bronze, silver, and gold for our Medallion architecture. Okay, so Databricks workspace has now been created, and let me launch the workspace. Let's have a quick look at the catalog, and we see that there is a catalog which is already created, right? Which is the same name as our workspace, and this is what we are going to use, right? I'm going to create 4 schemas. We can also create it through the SQL editor by using create schema statements, but let me use the UI for now, right? So I'll go ahead and create 00 landing, and I'm going to put it in the same location over here in the same storage location. Let's go ahead and create this. And okay, so all our schemas are now created. Our Databricks environment is now ready, right? So in the next part, we are going to create our first data pipeline using LakeFlow Connect to ingest data from our SQL server, which is the Azure SQL database, with change data capture. And this is where things get exciting. Let's do a quick recap of all of the things that we've completed until now. So number one, we have seen the streaming orders producer script, right? This was basically pushing all of the data into Event Hub. We created the Event Hub namespace and Event Hub itself, and we saw that all of the data was being pushed to Event Hub. Then we created synthetic data for all of this, which is your customers, restaurants, menu items, historical data, and reviews, right? I presented to you two options. Either you can take the data from the data folder or recreate the synthetic data yourself by running the script. We created the Azure SQL database, and then we used data grip, right? And of course, you're free to use your own client to be able to import all of this data into the SQL database, right? So we've completed all of the things until here. Now we are going to use LakeFlow Connect for CDC ingestion from SQL Server. Yeah, so we've already ingested the synthetic data sets into this SQL database, right? So we are now going to use LakeFlow Connect to ingest all of this data from SQL database into our Unity catalog, right? So these tables are going to be your historical order, your reviews, dim customer, dim restaurants, and dim menu item. Yeah. So LakeFlow Connect is a Databricks managed ingestion service. Basically, it abstracts out the complexity of connecting to your source system, tracking changes, and loading data incrementally, right? So no custom code needed for common sources like SQL Server, Salesforce, or SharePoint. So now let's go ahead and create this on Databricks. Let's go to job and pipelines, ingestion pipeline. Our source is SQL Server. We create a connection first. It is going to be through username and password, and let's name this as con restaurant ops, right? And let's see what the server, the host is, which is this one. Username is this one, and the password is this password. Okay, the connection is created, and now we see something unique, which is there are two parts to it, which is your ingestion pipeline configuration, and the second part is ingestion gateway configuration. Now, ingestion pipeline makes sense, right? It's going to ingest your data from the source. But what is ingestion gateway configuration? So, ingestion gateway is actually a dedicated continuous pipeline that acts as a data extraction engine, basically pulling snapshots and change data capture from the source database itself, right? And what it does is it stores all of this in a Databricks Unity catalog volume, which it calls the staging area. Yeah. And this is finally fed into the main ingestion pipelines for feeding data, for processing data into the destination tables, right? So think of ingestion gateway as a continuous pipeline which tracks changes, ingest it into a staging area, which is a Databricks Unity catalog volume, and then that is used by the main pipeline to ingest data into your actual destination table, right? And a very important point to note is that this runs on classic compute. Yeah. Let's go ahead and name this as ingestion gateway, and yeah, and we are going to create two pipelines. The first pipeline is going to ingest data into your bronze layer, and the second pipeline is going to specifically ingest data into the silver layer. So this is going to be pipeline ingestion bronze, right? And this is going to be the project. This is going to be bronze, and this one is going to be landing. Now let's go ahead and click on create pipeline and continue. Now, while we are waiting for the gateway to start, let me show you something interesting. Yeah. So if we go over to the compute, we see what it is trying to do is pin up a cluster, and this is actually a big cluster, right? The maximum it can auto scale up to 5 of such workers, right? And of course we want to avoid this at all costs, because we want to keep our cost under control. So we are going to create a policy, right? And unfortunately we are not able to attach policies, cluster policies, to LakeFlow Connect through the UI, right? So let's go ahead and create a policy over here, which is going to say, let's say this is going to be minimal compute policy, and there's going to be custom, and let's go to advanced, and this is going to be workers, the number of workers. The number of workers is going to be fixed, which is going to be 1, and the driver, we are going to select the kind of drivers and workers that will be allowed to use, right? So this one should be E4D and V4. Yeah. Then let's add another, which is your worker type. This is going to be F4S. F4S. Right. And by the way, these are the reason why I'm putting all of this is because these driver and worker types are something that is accepted by LakeFlow Connect. Yeah. Okay, this should be good enough. Now let's go ahead and create this policy. Let's add the same description and let's go ahead and create this. So now that this policy is created, I want to attach this policy to whatever compute LakeFlow Connect spins up, right? So that my minimum and maximum always stays between 1 and 1. Yeah. So I'll need to do this through the CLI. And for this, we need to have Databricks CLI installed, right? So I have this version installed, and you would also need to install this. And once it is installed, go ahead and run Databricks configure. We need to take up this URL and put it over here. This personal access token is going to be something that we are going to create from here. Generate a new token, and this is for the project. And I'm simply going to copy this and put it over here. Let me also save this over here. Yeah. So now this is done. Now I want to be able to list all of my pipeline, right? So let's quickly go ahead and run this. So these are the pipeline that have been created. Yeah. There is a gateway that was created, and this is the pipeline that we were just creating right now. Yeah. So I want the pipeline ID, which is this one for the gateway, because we want to attach the policy to the gateway. The gateway runs on classic compute. Yeah. Now, a very important thing to note is gateway runs on classic compute, but yeah, but your ingestion pipeline is going to run on serverless compute. So if I go to the previous one, this is going to run on serverless compute, and that is why you see that they ask you if you want to add a serverless usage policy, right? And over here they don't ask you any such thing, right? Because ingestion gateway is going to run on a classic compute. So now we go ahead and we have our pipeline ID. Now what I'm going to show you is, let me copy paste this from something that I ran earlier, right? So we are going to update this pipeline. Let's take the gateway ingestion pipeline ID and put it over here. And this is simply gateway ingestion. And the catalog, what was the catalog? So basically what we are trying to do is we are trying to attach the policy that we created. This is the policy that we created over here, which is your minimal compute policy. Let's take up the policy ID. Let's put it over here and attach it to this ingestion gateway. Let's check what was the catalog name. The catalog name is ws underscore dbx project. And the connection name, what was the connection name? The connection name is this one. Let's copy this. Let's put it over here. I believe this one is also going to change. And the gateway storage name, let's just put it the same as this. And let's go ahead and run this. Perfect, this runs. Now let's get back to this. Let me close this. Right? Let's go to job and pipelines. We see ingestion gateway. Let me stop this and let's run a fresh version of the ingestion gateway pipeline, and let's see whether the policy that we created was attached to the compute or not. Right? So right now, when we go to job compute, we don't see anything. Let's run this now, and we should see. Perfect. So now you see that to this compute, the minimal compute policy is attached. Now let me go over here, and you see that there are only one workers. Yeah, as compared to the 5 workers, the 5 count that we've seen earlier. Yeah. So now let's go back to our pipeline again. Let's go back to the ingestion pipeline. We click on edit pipeline. We are going to take up all of the tables which should be ingested in the bronze layer, and they are historical orders and this is reviews. Yeah, I don't want to change the names. Let's go ahead with this, and this is going to be in bronze. Save and continue. Okay, the validation is complete, and I won't add a schedule right now. Let's simply save and run the pipeline. Okay, perfect. Our tables have refreshed, and we see that there is a historical orders and a reviews table. Our bronze layer contains 2 of these tables, while silver is empty now. So let's quickly have a look at this. And I'm going to, before I start the serverless starter warehouse, an important point to note is, let's go ahead and quickly edit this to take up the 2x small, right? And let's put this to 30 minutes of inactivity. Yeah, and let's start this now. Perfect. So this is our sample data that has flowed in, and similarly for reviews. And let's also have a look if the data types looks fine. So this is fine. Review text, perfect. This is also fine. Yeah, decimal is as expected. Let's quickly also count the number of records. So we've already selected bronze. Select count star from historical orders. This should give me 8,000. Perfect. And this, I don't remember what was the number, but hopefully this will also be a non-null number. Perfect. So now we have the bronze pipeline working, which ingests data from our SQL server into the bronze layer in the Unity catalog. So now we are going to create the pipeline for ingestion of data into the silver layer, right? For creating the dim table. Yeah. So first of all, remember to make sure that you've turned both of these pipelines off. And because the gateway is a continuous ingestion pipeline, right, it will keep on running. So be very, very mindful that you've turned these two off. Yeah. So now let's create the ingestion pipeline. We'll use the same connection. This is going to be pipeline ingestion silver, and this is going to be silver. This is going to be gateway ingestion silver. I should have actually named the previous one as gateway ingestion bronze, but it's okay. To create the pipelines, this is created, and now we are waiting for our gateway to start, right? And we will need to repeat the same drill. Yeah. So we go over here. We simply say list all of our pipelines, and we see that there should be a gateway ingestion. Yeah, so you see the gateway ingestion silver. Now we are going to use the same command that we used earlier. Let's paste it over here. Yeah, and this is the pipeline ID for the silver ingestion gateway. Let me paste it over here. Let's paste this over here. This one over here. All the other things I believe are going to remain the same. The policy is going to remain the same, the minimal compute policy. And let's go ahead and run this. Perfect. So this is completed. Now let me cancel this. Let me close this. But you would see those two pipelines created over here, right? The gateway ingestion silver and the pipeline ingestion silver. Let me stop this and run this again so that the new policy is attached to the compute. Okay, now that this is stopped, let me run this again. And we are also going to run our silver pipeline. Yeah, first, before we do that, let's first do the mapping, right? The restaurant to dim restaurants, customer to dim customer, and so on. So we will wait for the gateway to start and then we will do the mapping. Okay, the ingestion gateway has been initialized, and now this time I only want to pick up customers, restaurants, and menu items, right? And for customers, I want it to be dim customers. For menu items, I want it to be dim menu item. These are directly my dim tables, right? So we are also going to look at the data model that we are going to create in the silver layer going ahead. So don't worry about it right now. Yeah. This is going to be dim restaurants. Yeah. And let's go ahead and create this. This is going to be in the silver layer. Save and continue. So now it has started to validate the pipeline configuration. Okay, the pipeline has been validated and is ready. Let's save and start the pipeline. Yeah. Okay, the pipeline seems to have started and now it is pulling up data for all of these tables. Perfect. We have 500 customers, 5 restaurants, and 145 menu items. So we've seen that our ingestion pipeline to the silver layer is now ready and working. But I would like to show another interesting thing, right? So I would like to show you how CDC would work. So let's go and change something in our SQL Server database and see how it reflects on Databricks. Remember to switch off the pipelines, all the pipelines and the gateways once you have completed the ingestion, right? So I'll stop the silver pipeline. We are going to use the silver pipeline for CDC ingestion, but the pipeline for bronze is not going to be used anymore, right? Because it was one-time data ingestion. Unless we want to do a full load again, we would not need to run the bronze pipeline. This one for historical orders and reviews. Yeah. Okay, so now in order to see how CDC is going to work, let's make some changes in our tables, right? So let me see how customers looks like, right? So we are going to change, let's say, one of the customers over here, the city where they are based in, right? So let's say this update customers set city equals, let's say, Abu Dhabi, where customer ID equals this one, customer ID hyphen 10,000, right? So let's first have a look at the SQL editor over here, and let's do a select star from 0 to silver dot dim customers, where customer ID equals customer. Let's run this, and we see this is Samuel Taylor based in Dubai. Let's go ahead and run this, right? So this has executed successfully, and let me check this quickly, and we see this has been changed, right? Now let's go ahead and make another change. So the total number of rows in menu items is how much? So let me quickly go ahead and insert one more item to this restaurant, which is item number 999. Let's go ahead and run this. Okay, so this has been inserted. Now if I do a count, this should give me 146. Okay, so there are two new things that have happened, right? One, we have updated the city for this customer over here, and number two, we have added a new item, yeah, to one of the restaurants. So let's go ahead and now run our pipeline, run our silver pipeline to see if LakeFlow Connect is able to identify the CDC changes. Yeah. So the gateway for silver ingestion is up and running now. We see that this is the compute that it is using, and it's important that the ingestion gateway keeps on running, right? Because we earlier understood that this is the one which tracks CDC changes at the source and then writes it to a Databricks volume, which is then picked up by our silver ingestion pipeline. Yeah. So let's go ahead and run this now. Perfect. So here you see two upsorted records, one for dim customer and one for menu item. So let's quickly go over here, and we've seen earlier that this was Dubai, and this should be Abu Dhabi right now. Perfect. So this works. Let's also select count star from dim silver or dim menu items. Okay, so it shows you 146 records. Let's also quickly see where item ID equals item 999, right? I believe this is what the item ID was. Great. So we see this row over here right now. So this is the advantage of using CDC and LakeFlow Connect. We don't need to write any code to detect any changes. Yeah, SQL Server tracks them, LakeFlow fetches them, Delta Lake merges them, and it is fully automatic. Yeah. So now as we conclude the LakeFlow ingestion from SQL Server, let's make sure that we have switched off all of our pipelines for now in order to keep the cost as low as possible. Yeah. Welcome to the concept vault. We are going to uncover Spark declarative pipelines, but if you are comfortable with Spark declarative pipelines, feel free to skip this section. So let's start with the first and the most important thing, which is why use Spark declarative pipelines. What are the problems that it solves, right? What exactly it is and what are the problems that it solves?
Why can I not go ahead and let's just use the notebooks, write my Spark code, and then use workflows to orchestrate everything, right? So there are two approaches, as already mentioned, there are two approaches for creating the pipeline. Basically, you write the PySpark or Scala or SQL code, and then we decide the job order, scheduling, error handling, cluster sizes, and then we glue all the notebooks together in an orchestrator, which is Databricks workflows, and schedule our jobs, right? So this is the most basic and widely used approach, right? This basically gives us a lot of control and flexibility. On the other hand, when you are using Spark declarative pipelines, you declare your tables and how to compute them, usually in SQL or PySpark, right? Now, what Spark is automatically going to do is that it is automatically going to figure out the dependency graph. So let's say you are using one table, it depends on five other tables. You don't need to make sure that notebook number one has to run before notebook number two. Spark declarative pipelines is automatically going to figure out the dependency graph, right? And it is going to decide the execution order, your parallelism. Yeah. And a very interesting thing to note is that it also handles the retries. If you're doing streaming, it handles the checkpointing on its own and the incremental updates on its own as well, right? And it manages both batch and streaming with the same definition. Yeah. So instead of us doing all of the things step by step, as you saw in the first approach, you basically tell them that these are my source table and here is the code for the derived table, right? And it runs the whole thing for you. You don't need to worry about your dependency graph, your execution order, how things are going to run incrementally, how are you going to manage the delta changes that are going to come, right? So all of this is going to be done by Spark declarative pipeline. And it does feel like magic because you are actually avoiding several lines of code which otherwise you would have had to write if you were not using Spark declarative pipeline. Now, many of you would have this question that how do I decide when to use Spark declarative pipeline, right? So whenever you have this question, ask yourself a few things, right? And one of them is, do you want the platform to manage the orchestration, reliability, changes the capture, slowly changing dimensions and checkpointing, right? Or do you need low level fine grained control over your pipeline, right? So use SDP when your work is mostly data pipelines, table in, table out, and you want more automation, right? The keyword, the important keyword here is automation than fine-grained control. So I'm going to walk you through 5 criteria that you should always think through when deciding whether or not to use SDP, Spark Declarative Pipeline. And the first one of it is SQL style ETL ELT transformation, right? So your pipelines, if they follow SQL heavy patterns, even if they are written in PySpark, SDP might be a good choice, right? Because SDP excels at declarative table to table transformations, right? And we are going to see what exactly we mean by declarative. Declarative simply means that you specify what you want to do instead of specifying how you want to do it step by step, right? So going ahead, we are going to look at a few examples, so don't worry too much about this right now, right? So the first criteria is SQL style, SQL heavy ETL ELT transformation. If this is one of the components of your pipelines, then SDP might be a good choice. Number two is you want automatic dependency management, right? So you want the platform to automatically order the table based on the code that you have written. Yeah. Number three is you want built-in streaming and incremental processing. Basically, you don't want to worry too much about watermarking, handling streaming concepts, or adding additional logic in order to read in incremental data. Yeah. So Spark declarative pipelines handle checkpoints for streaming and incremental data processing very well, right? So if this is one of the constraints that you have, that you don't want to worry too much about streaming, the logic inside streaming or incremental processing, Spark declarative pipelines might be a good choice, right? Number four is CDC, chain data capture, and SCD, slowly changing dimension pattern, right? So basically, Spark declarative pipelines has something called apply changes, right? It has something called apply changes. This API eliminates hundreds of lines of custom Spark code for, let's say, doing type 1, type 2 SCD, handling out of order events, and remove the need to understand watermarks and streaming semantics, right? So if you have such patterns in your code and you don't want to worry too much about handling the logic, writing the logic for CDC and HCD, SDP is a very good choice, right? And lastly, operational simplicity over flexibility. So as I said earlier, you won't have a lot of flexibility in the sense that you won't have too much fine-grained control, but your pipelines would be very simple. You wouldn't have to worry about things like CDC, SCD, streaming, incremental processing, dependency management, right? And SDP, Spark Declarative Pipeline, provide declarative functions, right? It provides declarative function, as I mentioned earlier, which reduces hundreds or even thousands of lines of code of manual Spark and structure streaming only to a few lines. Now, as I promised earlier, let's understand what does declarative mean exactly, right? How do we define declarative over here? We've been kept saying that SDP, D means declarative pipeline. What exactly is declarative in these pipelines? So what does declarative mean? Declarative simply means that we specify the what. Yeah, we specify the what instead of worrying too much about the how, right? So basically, let's say we have an input and we need to perform X, Y, Z transformation, and this leads to an output, right? So we basically say that we need the input and the output. We don't need to worry about how is the execution going to happen, what is the execution order going to be, how the dependency graph is going to look like, how my incremental data is going to be handled, how are all of these things going to happen. I don't need to worry about, right? So let's understand this with an example. Let's say if I were not using Spark declarative pipelines, and my flow looks something like, if I have a table, this goes through bronze and then silver and gold. Yeah. And this is in your notebook 1, notebook 2, and notebook 3 as specified over here. So this resides in one notebook, this code resides in the second notebook, where we read the bronze and then we produce an output which gets written into silver, and then in the third notebook we read silver and the output of this gets written into this gold table. Now we have three different notebooks and we would need to orchestrate this using, let's say, Databricks workflows and manage the dependencies, right? So this is approach number one. Now let's say we are using Spark declarative pipeline. So what we need to do is we need to specify that this is what should be the input and this is how the output should look like, right? So for silver, let's take a moment and first cover silver. What am I saying is that I need bronze orders, and whatever I return is going to be fed into this table, which is silver orders, right? So the way Spark declarative pipelines works is that the name of the function is the name of the table itself, unless you specify a name over here, right? So we basically specify that this is what I want, and I need the input to be the bronze orders table. So this is my input, and the return of this line is my output. Similarly for gold as well, I need silver orders, and this is the output that I want. The output is simply a group by and an aggregation. Now the beautiful part of it is I don't need to worry about whether notebook 1 needs to be before notebook 2, or it needs to be before notebook 3. All of this I don't need to worry about. Spark is going to look at this code and it is going to create a dependency graph of its own where it is going to have bronze, silver, gold, and then this is going to read from some delta file, right? And this dependency graph is going to be created on its own, right? All of that is going to be managed by Spark. So you see that this has been made so easy. The amount of code that we've written here versus what we've written here has reduced significantly. And this is a very simple example that I've given you. If I were to give you a complex example of, let's say, CDC or SCD, and we'll be covering that going ahead. So you'll understand that this is really, really powerful. The second example to understand declarative is your CDC and SCD, which is slowly changing dimension processing, right? So let's say we have a table called dim customers, and this is going to be an SCD type 2 table, right? What that means? That simply means that when a customer, when some attributes for a customer is changed, we basically track history, right? So let's say if my initial location was in India, now I have moved to Singapore, I am going to have two rows which is going to say that my location was in India from valid from date number from date start to date end. And then I'm going to have another row which is going to say that now my location is Singapore. The valid to, so sorry, the valid from is going to be today's date, but valid from is going to be null, saying that it is the active record. Now, if we were to do this not using Spark declarative pipeline, we would initialize a CDC stream where live data is coming in, and then this is the already existing dim customers table, and then we would have to write a bunch of logic over here to handle the upserts, deletes, and updates of customer record. And then we also need to manage the effective date, which is the start date, and the end date, and whether this record is current or not for each of the records for every customer. We also need to handle out of order events, and then we also need to implement custom merge logic, right? Now, once all of this is done, we finally write the stream data into a given location, right? So you see that we need to do a lot of steps until we reach our final goal, right? Now, if we were using Spark declarative pipelines, what we would simply do is we would specify the target. Our target is dim customers, and the source where streaming data is coming in or CDC data is coming in is CDC customers over here. The key that we want to upsert on, or I should not say upsert, because basically the key that we want to compare on, for example, my name should have two records. So the key that we should compare on is customer ID. We should sequence by updated at, and SCD that should be followed is SCD2, right? So you see that we wrote this much code versus this much code, right? And this is very simple to understand, very simple to write. So going back to the previous statement that we made is that we don't worry about the how are things going to be executed. We just worry about the what, right? What is going to be the input and what is going to be the output, right? So this decides the output, right? So this is what declarative is. Let's go through some of the key concepts that we need to understand before we start working with Spark declarative pipeline. And I'm going to use this diagram over here, which has been taken from the Databricks documentation, right? And this is a very interesting and important documentation. So you see that the first path over here is the streaming path, and the second path over here is a batch path, right? This is a streaming batch path, and this is a streaming path. Now, the first row that we are going to explore is the streaming path, and we have a streaming source. And this streaming source can basically be things like Kafka, Event Hub, Kinesis, PubSub, right? So this is your source, and this is then the new records that come in through the streaming source is going to go through stream processing, right? And when it goes through stream processing, you have two options. It can either go through an append flow or it will go through the auto CDC flow. But let's take a step back, right? What exactly are these flows over here, right? So a flow is a foundational data processing concept in Spark Declarative Pipeline, and it supports both streaming and batch, right? Supports both streaming and batch, and it basically reads data from a data source, applies user-defined processing logics, and write the result to a target, right? So very simple. A flow basically reads data from a source and then it applies some kind of logic over here, right? And then it writes to a target, right? So we have two kind of flows, append flow and the auto CDC flow. Append flow, as the name suggests, is very simple. It's basically a streaming flow that reads in the new records from a streaming source and append them to the target, right? Without updating or deleting the previous rows, right? Takes the rows from the streaming source, appends them to the target without updating or deleting it, right? So that's the append flow. Now, what is an auto CDC flow? An auto CDC flow is a special type of streaming flow that understands CDC events, right? It understands change data capture events and it automatically maintains slowly changing dimensions, right? So if we want our tables to be SCD type 1 or SCD type 2, an auto CDC flow understands that and it will make sure that our output table is following relevant SCD, right? Is following the relevant SCD, right? So the benefit is that we don't need to worry about out of order events or write complex streaming logic in order to make sure that either CDC works properly or slowly changing dimensions type 1 or 2 works properly, right? And this can go into two types of target. The first one is your sync, and this is the generic streaming targets such as your Delta table, Kafka topic, Event Hub, or other outputs, right? And a streaming table is a Unity catalog managed table that is continuously updated by one or more streaming flows, right? So there can be one or more streaming flows which can update this streaming table. Yeah. And finally, we have the batch path in which we have a batch source. Now, this batch source can be anything like a file in your storage, existing tables, or streaming tables materialized as of a point in time, right? Now, this data coming in from a batch source goes through materialized view flow, right? So, a view flow is another interesting component in which your data is updated incrementally, right? So it reprocesses only new data or change data coming from the source rather than recomputing everything. Yeah. So a very important and interesting thing that I've noted is every time it's not incremental. So what Spark does is it tries to make all of this, the logic, go through a cost model, right? And after it goes through a cost model, it then decides whether it should be incremental or it should be a full compute, right? Wherever possible, wherever possible, it tries to do an incremental run to avoid cost and then make it performance optimized, right? And then finally, all of this data is written into this materialized view. Yeah. And materialized view is again a Unity catalog managed table whose contents are defined by the query. So in this project, we are going to use both streaming tables, right? We are going to use both streaming tables and materialized views. Yeah. Okay. So I hope now you understand Spark declarative pipelines and will be able to understand the project in a more meaningful way.
So we've got batch data flowing from the SQL server. Now we are going to handle real time. Yeah. We'll be creating a Spark declarative pipeline that is going to consume orders from Event Hub and write them to a bronze table in Unity catalog. Yeah. And once this is done, we'll do a one-time load of historical orders that we loaded from the SQL server. Yeah. So let's quickly go ahead and create an ETL pipeline. We are going to name this as pipeline ingestion event hub. Let's start with an empty file. And let me rename this to eventhub.py. And before we start putting all of our code for ingestion of data from Event Hub, let's add an exploration notebook where let's first test our code over there, and then we will move our code to the declarative pipeline, right? Let's name this as Event Hub. Yeah. Let me also quickly create a small cluster that we'll be using for our experiment over here. We don't need photon acceleration. This is going to be single node, and let us terminate this after 30 minutes of inactivity. Yeah. And we see that this is going to cost us only 0.75 dpu per hour. Now while this is spinning up, let's see how do we ingest data from Event Hub into Databricks. And if you look at this reference code, we basically take all of our details from the Event Hub and then form all of the Kafka parameters over here, and then we use it over here to read data from the Event Hub, or very interchangeably the Kafka topic, right? So similarly, what we've seen over here, right? I've created something similar, and at the top, what we are going to do is we are going to configure our Kafka connection. Yeah, and let me put this over here. Yeah. So Event Hub basically speaks the Kafka protocol, so we can use Spark's Kafka source. Yeah, the Bootstrap server that we see over here is basically the Event Hub namespace, and the subscription to the topic is basically the Event Hub itself, right? The orders topic that we were referring to. So let me quickly create all of these parameters over here, eh underscore name, and then finally the connection string, right? So this is now Databricks wanting to read data from Event Hub. So let's quickly go over here. We go to Event Hub. The name of our Event Hub is orders. So this is going to be orders. This one is the namespace. We put this over here, and the connection string is going to be, we go to shared access policy, and then we go to Databricks read policy. We copy the connection string from here, and we are going to put this over here. Yeah. I hope okay, our cluster is ready, and we run this. Okay, let's run this. And now let's quickly let's create a raw data frame. Df raw equals spark dot read stream, and dot format is going to be Kafka, and the options is going to be, okay, perfect. This is what it is going to look like, and I'm simply going to do a display of df raw. Yeah, so now let's go ahead and run this. So while this is initializing, let me quickly explain you some of these parameters over here, right? So a very important one is your starting offsets, right? This is basically set to earliest so that we read from the beginning of the stream. Max offset per trigger basically limits how many messages per batch we want to process, right? So basically it helps control the usage, the resource usage. Yeah. And finally you have fail on data loss, which is set to true. So fail on data loss is a Spark structured streaming Kafka source option that controls what is going to happen if Spark detects that some Kafka data that it expects is no longer available, right? So basically what exactly is going to happen if Kafka, if Spark is expecting some data from Kafka, but it is no longer available to read. Yeah. So for us, we've set it to true. That means it would fail in such a case. Yeah. So right now it says no rows returned. Yeah. Let me quickly get this stream running. So this should be Python event hub orders.py, and this should get data flowing into this, right? So you see that the graph is rising up. Yeah. And now you see some value over here. Yeah. And then this is from the orders topic. There's only one partition that we've created right now. Yeah. So now let's do something. Let's parse this data frame. Yeah. So let me pause this for now. Let me also pause this. Yeah. And let's go ahead and parse this data frame. So df parse is going to be your df raw, and let's go ahead and add the key column. There is some key and value over here, right? So let's just take it as string. So we are going to take it as key str, and this is going to be column of key, and we'll convert it to string, right? And this seems like we've not imported from pyspark.sql.functions import star. Let's run this, and this should go away now. Yeah. And then we are going to do the same thing with value as well. Your value str is going to be value over here. Yeah. And now before we do anything to retrieve our data set, right, let's first go ahead and print this display df parse. So basically we now see that key is null, that is okay, but values, we have the whole order data over here, right? We have all of the order data over here. Yeah. So now what we are going to do is let's quickly add another column, which is with column, and this is my data. And because this is a JSON, I'm going to parse this JSON. Yeah. So let's do from JSON, and this is going to be value str, and we need to pass in a schema over here, right? The schema for this order over here. Yeah. And the schema is going to look something like this. The schema is going to look something like this. And let me also import from pyspark.sql.types import star. Let's run this, and this should work fine then. And then I'm going to specify the order schema. Yeah. So let's run this again now. Okay, so now we see a column wherein we have JSON. So now you see it properly formatted as a JSON object. Yeah. And this belongs to the data field, right? So what we are going to do is we are going to simply select all of the fields in this data column over here, right? And then let's also add rename. So you see that there is a timestamp column over here. So let's just rename this as timestamp to order timestamp, right? So what we've done is we've taken in the key and value, key was null, and we parsed the value to a string. After parsing it to a string, we basically got a JSON, but in a string format. We've converted it into JSON by using from JSON over here, and this belongs to the data column. Now we are simply going to select all of the columns in data, in the data JSON, right? And we are simply renaming timestamp to order timestamp. Let's go ahead and quickly run this now. Okay, perfect. So now what you see is the data that was being generated over here, right? All of this that was being generated over here. We see the order ID, order timestamp, restaurant ID, an array of items, the total amount, payment method, and order status. Perfect. This looks good. So now let's go ahead and create a Spark declarative pipeline out of this, right? So we are first going to pause this, right? And let's take all of this from here. Yeah. Let's also import from PySpark, import pipelines as DP. Yeah. And we are then going to take all of this and put it over here. And then let's also take up the Kafka options. Now, one thing that is very important to do is let's go to settings. We are going to select add configuration. This is going to be my value, and this is going to be the key namespace. This is going to be your order eh dot name, and then this is going to be my endpoint, yeah, which is going to be eh dot connection string, right? And I'm going to simply change this to spark dot com dot get, and this is, let's replace this with eh. This is going to be replaced with spark dot com dot get eh dot name, and this one is going to be replaced by spark dot on dot get, and this one is the connection string, right? So now we have all of the data that is needed to build up your Kafka options. Let's save this, yeah, and then we are going to create the pipeline, right? So this is going to be through a function orders, yeah, and let's paste all of the code that we've created over here, yeah. So we first create a raw data frame. Now once the raw data frame is created, we then create the parse data frame, yeah. The parse data frame is this one, and it also needs the schema. The schema is over here. This one is your schema, yeah. And we are simply going to return this, yeah. We are simply going to return the df parse data frame, right? Now in order to make Spark declarative pipeline understand that this is a table, right, we need to add the decorator dp dot table, right? And we are going to put the name equals orders, right? And we are going to add some table properties, which is a dictionary. You can specify multiple things, and we are going to provide quality equals bronze, right? Now an interesting thing to note is if you skip this part, right, if you skip the name, it is going to take up the name of the function, which is orders, and it is going to create a table with that name, right? So let's go ahead and quickly do a dry run for this. But before we do a dry run, let's check the cluster. So the compute that it is using is serverless, right? So let's do a dry run quickly. Okay, so the dry run has succeeded. Now we are going to run the pipeline. Okay, so it shows me that there are 17 outputs since the beginning of time, right? So if we've specified this as earliest, right, there are 17 records which is present in the event hub that we've read, right? Let me also go to the SQL editor and show this to you. So this is select. So we have this, and then in bronze we should have orders. Okay, did I create it at the wrong place? Okay, my bad. I created it in the default schema. This should be there in the bronze schema. So let me run it once again, and let's do a select star from bronze, not orders. Let's also do a count star. Yeah. Okay, so the pipeline is complete, and I believe I should see something in the bronze layer now. Okay, there you go. We have orders, and let me quickly do this. Okay, so we'll just quickly attach and run this. Okay, there you go. You see 17 orders, but let me also run this. Yeah. Okay, so now we have our orders, our order data from the Event Hub being ingested in streaming mode into a table in the bronze layer. Yeah. So I'll click on terminate, and I'll terminate this compute just to make sure that there's no other compute running. This one is for the notebook that we created, but let's terminate it for now because we don't need it. We've seen that we have around 8,000 orders in our historical orders table, right? And we've just now created a streaming orders table as we've seen over here, right? So dp.table creates a streaming table, and we basically want to load all of the historical orders in our current orders table, which is the streaming table that we created, right? So we are doing a one-time dump of historical data into our actual orders table, right? So let's quickly go ahead and do that, and for this we are going to do insert into 01 bronze dot orders. I believe a select star should just work given that the schemas of both the table are the same. Let's quickly do a count star before this, right? And let's do a count star after this is done. Okay, so the number of rows inserted is 8,000, which is all of your historical order. And let's look at how the data looks like over here. And we see that it just looks fine. Yeah, it just looks fine. So now this should have 8,017 records. Yeah. So now this basically inserts all of your historical records into the same table that is receiving your live order data. Yeah. So we've configured real-time orders streaming from Event Hub, and the historical orders merged in, and LakeFlow Connect is syncing our batch ingestion. So going ahead, we are now going to use this data for doing different kind of transformations in the silver layer. So next up, we'll be creating the silver layer. This is where the raw data becomes reliable, typed, and enriched, right? And here is where we are going to create our data model. So let me quickly walk you through the data model that we are going to create. It is going to have 3 fact tables, right? And 3 dim tables. Yeah. So let me zoom into this a little bit. So we are going to have fact orders, fact order items, and fact reviews, right? What are all the orders? What were the items inside those orders? And what are the reviews from customers, right? And the dim tables are your dim restaurants, dim menu items, and your dim customers. Yeah. So let me also quickly talk about the relationship between these tables. So one order that you see over here can have many can have many order items simply. Yeah, that is number one. One order can be placed from one restaurant over here, but one restaurant can have many orders, right? And rightfully so. And then you see that one order can belong to one customer, but one customer can place many orders, right? And similarly, one order is going to have one review, right? If I placed an order, I'm going to put in one review for that order, and one review can only belong to one order. Yeah. And then we similarly have other relationships signifying, let's say, relationship between dim restaurants and dim menu items. Yeah. So one restaurant can have
several menu items, but one menu item is going to belong to one restaurant. Yeah. So this is the overall data model that we are going to create in our silver layer, which is going to be used downstream in the gold layer for building all our aggregate views. Yeah. So let's go ahead and create the fact orders table in the silver layer. And you might ask me how it is different from the orders table that we already have in the bronze layer. So we are going to add new attributes, and they're going to be this one: the order hour, day of the week, is it weekend, the item count, right? So this is going to help us do analytics, basically build KPIs downstream in the gold layer. So let's create an ETL pipeline and let's name this as pipeline transformation silver, and let's start with an empty file. Yeah. So I'll rename this to factorders.py, and we'll also be adding an exploration folder. Let's also name this notebook as fact orders, right? So here is where we are going to do all the experiments. Yeah. So let me first copy and note down the schema of the fact order table that we'll be creating, right? So this is the schema, and now we are going to read in our bronze table, right? Order equals spark dot read. So this is going to be spark dot table bronze dot orders. Yeah. And we need to create order timestamp, and this is of timestamp type. Let's quickly check what is the data type in the bronze layer. When we ingested this table, so the data type is string over here, right? The data type is string, but others are fine. The total amount is double. So now we are going to simply do a with column, and this is going to be order timestamp, and let's do a two timestamp. Okay, let me quickly import from PySpark.sql.functions import star, and this is going to be two timestamp column of order timestamp. Yeah. Now the next one is order date, and this again is very simple with column order date, and this should be to date column order timestamp. Yeah. The next one is order hour. This is again very simple. This should be hour. Yeah. And finally we have the day of the week. The day of the week is going to be a little different. So this is day of week, and what we do over here first is we check the date format, right? We check the date format, and we do this in this form. Let's use this date format, the day of the week, and we do it in EEEE, which basically gives you the full name, which is Monday, Tuesday, Wednesday, the full word. Yeah. And then we check whether it's a weekend or not. Yeah. So in order to check whether it's a weekend, what we do is we are going to place this in a f.when, right? Let's remove this, and great. This is very helpful, right? I don't have to write a good amount of code. Yeah. And then we already have restaurant ID, customer ID is already there, order type is there, item count. So we need to compute item count, but we've seen here is that we have items which is a string. Yeah. But it contains a JSON, an array of JSON. Yeah. So let me quickly show this to you again. If we do a select star, if we see items, this is basically an array, and inside the array it contains a string, right? So
what we are going to do is we are going to create another column which says items parsed, and this is going to be from JSON, and the column name is items. Okay, items, and we need to specify our schema over here, the item schema. Yeah, so I've already created the item schema, and it is going to look something like this. Yeah, so let me paste this over here, and we need to import from PySpark.sql.types import star. Let's run this. Yeah, and then we've passed in the item schema over here, and we finally do a count of items parse, right? So we do a with column item count, and this is going to be the count of items parsed, right? So let's go ahead and just do a display of the df orders, or maybe let me rename this as fact orders. Yeah, and let's go ahead and run this. Okay, we seem to get an error, but before that I believe this should be size and not count. Okay, so let's have a look if the column that we created have been added over here. So you see order timestamp, and let's have a look at the data type, which is timestamp now, and this has been very neatly put in the structure that we shared over here, right? So we added day of the week, weekend, and your item count. Okay, this works perfect. So let's select the final set of columns that we need for fact orders. Yeah, so this is going to be your order ID, order timestamp, order date, order hour, your day of the week is weekend, your restaurant ID, customer ID, order type, item count, total amount, and let's actually convert total amount to decimal for consistency. Yeah, that is done, and we add payment method and order status. All of this is not needed. Yeah, let's finally do one more run before we save this. Okay, there's some syntax error near the end of input, and it's basically this bracket missing right over here with the order hour cannot be resolved. Okay, so here I have created order date instead of order hour. Now let's run this again. Okay, so we see the order date, order hour, day of the week is weekend, item count, total amount, and the order status. So this looks like a very neat and clean fact order table. So now let's move this to the Spark declarative pipeline, right? So I'm going to copy all of this over here. We also need one more import, which is from PySpark import pipelines as your declarative pipeline. Yeah. And then we are going to create a function where I am going to place all of this. Yeah. So let's go ahead and create a function named fact orders. Yep. And then we have to return this fact orders table. Let's remove the display from here, and in order to make this a streaming table, we have to do add dp dot table, and the name is going to be fact orders. Yeah, because I've selected the schema over here, I need to change the schema as well. This is going to be in the silver layer, so this is going to be fact orders, And you remember that we added table properties, and this is going to be quality equals silver. Yeah. So let's do a dry run for this table. So the issue is with fact orders. This needs to be df fact orders. Okay, this works perfectly fine. Now let's run the pipeline. So we see that we have ingested around 8k orders, right? So let's go ahead and have a look at this. Okay, let's also do a little bit of count over here, which is your bronze orders over here. This had how many? 8017. And when we do a count star from 0 to silver dot fact orders, this also has the same number of records. So there's a very interesting thing I want to show you now, and that is data quality in Spark Declarative Pipeline. So we can directly add data quality checks to our pipeline over here, right? To our fact orders pipeline. And the kind of checks that we can add is basically, let's say you have a table and then we place an expectation, a set of expectations on those table, and if it passes, well and good, we keep that record. If it fails, then you have three options. You either drop, right? You either drop the row from the final output itself, you fail the flow, you fail the pipeline that is running, or you simply warn and keep the record. Yeah. So the way we do this is basically placing something like this: add dp.expect, and then we place the name of the expectation and a SQL expression over here, right? So this is going to look something like this, and we are going to do it on our fact orders table. Yeah. And there are the options that you have for an invalid record is either you drop it, and we drop by simply placing dp.expect or drop, or we fail the flow by simply saying dp.expect or fail, right? Some examples are over here: expect or drop, expect or fail. So let's say we are going to use expect all or drop, right? So there's something called expect all or drop. Yeah, so this is expect all or drop. So what expect all or drop means is that we are going to have a list of expectations, right? So all of those expectations should be passed. If any one of them fails, then the row is dropped. Yeah. So let's go ahead and write all of those expectations. So we are going to say dp dot expect all or drop, and this is simply going to be a dictionary over here, right? Or let me better format this as something like this. Yeah. So we are going to put some expectations on, let's say our order id should be non-null. So the first expectation is going to be valid order id, and this is going to be simply how we would write it in SQL: order id is not null. Yeah. Similarly, your order timestamp should not be null, right? Order your customer ID, your restaurant ID, all of this should not be null. Yeah. So we are going to place all of this over here. All of this is going to be placed over here. What are some of the other checks that we can include? Some of the other ones are, we have the item count, right? So logically speaking, the item count should be greater than 0. So let's also put valid item count, and this is going to be item count should be greater than 0. What else? We have order status. So the order status generally is should be some of the valid categorical data type, right? So let's say it should be either completed, pending, ready, or whatever, right? So we are going to import, we're going to basically put this check over here. Yeah. Then we are also going to have some kind of categories for payment methods. Yeah. So for payment method, let's put this one, which is valid payment method. And this is going to be payment method in, this should be in a list, and this should simply be either your cash, card, or wallet, right? And finally, uh, we have the total amount, right? Again, the total amount should also be zero, greater than zero, not zero. So this would be valid total amount, and this should be total amount should be greater than zero, right? So we have defined how many? 1, 2, 3, 4, 5, 6, 7, 8. 8 checks on our table, right? So let's go ahead and run this. Let's first do a dry run. Okay, this works fine. Now let's go ahead and run our pipeline. So you see that we don't have any outputs over here, right? The reason because we've already consumed all of the data. Yeah. So I'll show you the outputs going ahead. Yeah. However, an interesting thing to note is that there are expectations which have been registered, and you see that there are 8 expectations that we defined, right? There have been no actions because of course there were no records in our flow. So now let's go ahead and create fact order items, right? So this table gives us item level granularity. And why is this table important? This is important to be able to help us answer questions like what is our best selling item, which category generates the most revenue, and things like that, right? So I'm going to create another file for our fact order pipeline. Yeah, this is going to be the first one. And then let's also create a notebook. Yeah, and this notebook is going to be named fact order items as well. Yeah. So what are the attributes or the columns that is going to be present in fact order item? Let me paste it here. So these are the items. So this is basically at an order ID, item ID level. Yeah. Let's create, let's do the imports from PySpark.sql.functions, import star, and let's also import PySpark.sql.types, import star. Yeah. So now we are going to read the bronze orders table. Yeah, so this is going to be df fact orders, and we are going to read the bronze orders table, right? Spark.table 01 underscore bronze dot orders, right? Now we have to create the following items, which is item ID, restaurant ID, timestamp. Order timestamp can be created directly from the orders table. So we are first going to create that with column order timestamp, and this is what it's going to look like. Order date is also going to look like this. Order year and order month, we don't want that, right? So this is okay. Yeah. And now we are going to create something called item parsed, which we created earlier as well, right? So this is going to be item parse. Perfect. uh, this has to be the schema over here, and let me copy paste the schema for you. We used the schema earlier as well. So this is our schema. Yeah, and this is your item schema. And first of all, let's quickly see how this looks before exploding. So we have a JSON, an array of JSONs, and we are going to explode it. What that means is that for one order, there was one array of all the items, right? Now we want to explode it so that each item becomes one row. Yeah. So let's do a display of df fact order, but there's some issue here. What exactly is the issue? Okay, there's a missing bracket over here. Yeah, so let's now run this. Okay, so the item parse, this is the item, which is the string item parsed. This is an array, right, as it has rightly figured out, right? So now we want each of these items to be one row itself, and all of the other values will be duplicated, right? So what do? We simply do with column, and because this is a single item, I'm naming this as item, and it is going to be all explode. This is right. Yeah, yeah. And now let's have a look at it once more. Yeah, so let's look at this order. This order has these many items, right? It has this chicken tikka masala, masala chai, butter chicken. I don't know who has chai with chicken tikka masala, but you see that this first item is your chicken tikka masala, and then this is masala chai, right? So that means the explode has worked. Now we have different rows. We have separate rows for each of the items in an order. Yeah. So now let's go ahead and select the final columns for fact order items. And this is going to be your order ID. The next one is going to be item ID. And the way we select item ID is simply item dot item ID over here, right? So this is going to be column item dot item ID. Okay. This works fine. And then you're going to have restaurant ID, order timestamp, order date, and all of the other attributes related to the item, right? You're going to have item name, item category, item quantity, unit price, and subtotal, right? Now, a very important point is, in order to avoid floating point precision issues, we are going to convert all of this to decimal. Yeah, to decimal, and this is going to be 10 comma 2. And let me quickly copy this. You're going to put this over here. Yeah, so this looks fine right now, and let's go ahead and run this pipeline for one more time. Okay, this is your order, this is the item ID, and then it has properly listed out the item name, the category, the quantity, unit price, and the subtotal. Yeah, so now let's aim to put this inside of fact order item. So we are going to paste this over here, and then we're going to add another line from PySpark import pipelines as dp, and let's put in the other pieces of code, and we are going to name this function as fact order items. Let's dump all of the code here. Let's indent this, and this is going to be read stream, as we discussed earlier, dp.read stream, and let's return this different. Yeah, and in order to initialize this as a table, as a streaming table, this is going to be dp dot table. Your name is going to be fact order items, and table properties is going to be quality equals silver. Yeah, let's do a dry run. So the dry run seemed to work fine. Let's go ahead and run our pipeline. Okay, so it has ingested around 24K records. Yeah, so this means that our ingestion pipeline has worked just fine. And let's have a look at the record. Perfect. Now let's also add data quality checks as a part of this fact order items tables, right? And we'll do it the same way that we did earlier, which is going to be expect all or drop, right? And this is going to be something like this. So we are going to first make sure that things like order ID, item ID, restaurant ID, and what else? Order timestamp is not null. So we'll place the checks, which is valid order ID. This is not null. Very good. And item ID, let's also put in the restaurant ID and valid order timestamp, right? This is good. We don't want to add all the other non-null checks. Some other interesting checks that we might add is the quantity. The quantity that we see over here is, of course, should be greater than 0. Unit price should be greater than 0, and subtotal should be greater than 0. Yeah. Okay, this works. Now let's do a quick dry run. Okay, so we see that 7 expectations have been defined over here. If I run the pipeline again, we wouldn't see any orders because we've already consumed the 24K orders, right? So there's no new order that has come in right now. But still, let's run the pipeline to see if the expectations have been registered or not. Okay, as expected, there are no outputs. We will see the output going ahead when we run the pipelines again. Yeah, but we see 7 expectations which have been defined over here. Now come the most exciting part, and we are going to build fact reviews with AI powered sentiment analysis, right? And this is where Mosaic AI integrates directly into our pipeline. Yeah. So we are going to go to serving, and when we look at this, right, we see that there are several models that we can use. Yeah. So if I click on, let's say, this model, there is a ready endpoint that I can invoke to get outputs, right? So I'm going to simply use the AI query function provided by Databricks. An AI query is a built-in function that calls an AI model endpoint with a given prompt, right? So basically you call an endpoint, provide a prompt, and then it returns the output. And the prompt that we are going to provide is going to ask the model to analyze reviews and return a structured JSON with two things. Number one is your sentiment, and then the issue categorization. So it takes up the review text, the reviews table that we have in the bronze layer. Yeah. And then it is going to use that text to be supplied to the model, and the model is going to then analyze our text and return us two things. Number one is your sentiment, number two is the issue categorization. So this is the AI query function that I was talking about, and basically you can provide in the endpoint of the model and your request. So let's take a look at one quick example. So this one is basically a Databricks MetaLlama model, and then this is the prompt that we provided, right? And then this is going to return us a string which is the output of the model. Yeah. So first let me exactly show you what are we going to build in fact reviews. Yeah. So let's head over to our SQL editor, and I'm going to put in the columns, the attributes that we are going to have in fact orders. Yeah. So it's basically there's going to be an analysis JSON which is going to contain the response from the model. So we are going to take the review text, send it to the model. The model is going to tell us that, hey, this is the review sentiment. It is either positive, neutral, or negative. And along with that, we are going to also classify issues, right? So either the order had a delivery issue. If it did, then what was exactly mentioned in the order review which made it feel like a delivery issue, what was the reason? And similarly for all the others, right? Because if you think of it from a business point of view, this is what they would want to look at and then drill down and optimize, right? Make correction. So looking at this AI query function, what we are going to do is we are going to use this table, the review table that we ingested. So this is going to be something like select star comma AI underscore query, and here I'm going to place in the model, and here we are going to have the prompt. Yeah, so before I paste in the prompt, let me put this as 0101 bronze dot reviews. Yeah, and let's paste in the prompt over here. The prompt is going to look something like this. What the prompt says, the prompt basically says analyze the following review and return only a valid JSON object with this structure. And what is the structure? The structure basically contains your sentiment. It's either positive, neutral, or negative, and then it flags whether there was an issue with the delivery or not, and if it was, then what was exactly the reason that was specified within the review text, right? And then finally we attach the review text, which is the column from this bronze review table, and let me rename this as analysis JSON, which is what we were talking about, right? So now to be able to select which model we want to use, and for now let me select the most cheapest one. This one is input 1 dbu per million tokens. So let's just go ahead and use this and go back to the SQL editor. Yeah, so this as analysis JSON should be over here. So now let's run this. Okay, now we have the output, and let's see this. This is going to be interesting. So we have the analysis JSON, and this is sentiment positive. This did this have a delivery issue? No. So this didn't have any other issue, right? Let's look at the negative, right? So the negative says what was the issue? The food. It was a food quality issue, and the reason specified is disappointing desserts and burnt edges on sweet lassi. I don't understand what burnt edges on sweet lassi means, but it looks like something was not right. Yeah. So now we have the analysis JSON, but this is a string. We need to convert this. We need to extract out the columns over here, the keys, right? So the way we do it is as follows. We are going to use something called, okay, first let's wrap this in a CTE, yeah, with model response as, let's just pick this up and we are going to put it here. Let's correct the indentation, yeah. And the way we will be able to read the response is by using get JSON object, right? So we are going to do something like select, let's say we select the review ID and we do a get JSON object, and we know that this is a JSON string object, right? This is a JSON string object, analysis JSON, and this dollar sign basically refers to the root of JSON, right? JSON output. So we are saying that we want sentiment, the key sentiment at the root, and this is going to be one column, and then this one, the issue delivery, is going to be another column. Let's first just select this and run this from model response. Let's just run this and see what the output is. Yeah. Okay, so we can see that the sentiment and issue delivery has come out properly. Now we'll do this for all the other fields. Yeah, so this is going to look something like issue delivery, get JSON object, analysis JSON. This is going to be dollar issue delivery reason, right? And this is going to be text, so that is why we are not going to make any changes. There's going to be issue delivery region, and similarly we are going to do for the others as well. Yeah, so now we have all of the columns for classifying the issues. Yeah, let's put the other columns as needed, which is review ID and then your order ID, customer ID, restaurant ID, your rating and the review text. Let's also put the analysis JSON object just in case we want to refer to it later. And finally, your review timestamp, right? When was this review given? Let's look at this final output. So now we see the outputs, and let me just quickly scroll this up. So this is interesting. So this is a positive sentiment, and if we look at some of the issues, which is food items were disappointing, sweet lassi was burnt on the edges. Again, I don't understand what that means because yeah. So there was an issue with food quality, and the sentiment was negative, which makes sense. And then this was issue delivery reason, minor issues with packaging. So that means issue delivery is true, but the sentiment is positive, right? So let's have a look at the sentiment, which says solid experience, blah blah blah. Everything was well prepared. They had great flavor, but there was a minor issue with packaging, right? So this is interesting. This helps us understand whether the sentiment was positive, neutral, or negative, but it also highlights the issues, right? The issue with the orders. Okay. So now we are going to be creating a table, a streaming table using this SQL query that we've created over here. Yeah. So let's go ahead and let's go back to our pipeline, and let me now add a file which is going to be SQL this time, and this is going to be fact reviews. Yeah. So I'll copy this SQL query that we've written over here. Yeah. So this gets copied over here, and we are simply going to create a streaming table. So the command to do that is create or refresh streaming table. This is going to be 02silver dot fact reviews. Yeah. As, and then all of this. Yeah. So let's do a dry run very quickly. So this dry run seems to work fine. We have not defined any data quality checks right now. So let's go ahead. Let's go ahead and run the pipeline for now, and we'll define the data quality checks a little later. Yeah. Okay. So there is an issue. Cannot create a streaming table. Append one's flow. Okay. So I believe this should be a streaming table, right? This one. Now let's run our pipeline once again. So this seems to be running. Great. This is complete, and we have 78 reviews that have landed in the fact reviews table. So let's go over here. Let's create a new query, and let me do a select star from silver dot fact reviews. Yeah. Let's run this, and there you go. So you have your review ID, which order does it belong to, which customer has given the review, and which restaurant does it belong to, the ratings, the review text, analysis JSON, and then classification, your sentiment, and the classification of issues, right? Perfect. This looks good. Let's add some data quality checks to our pipeline. And last time we added it using Python. Let's quickly have a look on how to do it using SQL. So we specify the constraint name over here, which is the same as, let's say, valid order ID that we specified earlier. And then we put the expectation, right? But how do we specify what to do on, yeah, what to do on getting an invalid record? So there are two options, which is dropping the row or failing the update over here, right? So let's look at an example, which is this constraint valid current page, and then we put this over here. And on violation, there is a drop row. Yeah. So let's do something similar, and we are going to create this over here. So this is going to be constraint valid sentiment, and we are going to write and expect the sentiment in This should be either positive, neutral, or negative, right? And on violation, what are we going to do? On violation, we are going to drop the row. Yeah, this makes sense. Now let's add another check for the rating. So this is going to be constraint valid rating, and this is going to be expect rating greater than 0, and on violation drop row. Yeah, let's do a dry run. So the dry run has completed. Now let's run the pipeline. You won't see any records again for the same reason that we've not pushed in any records, but the registration of the expectation should happen. So we see that there are two expectations that have been registered. Yeah. So the silver layer is complete now. We now have clean, typed, and enriched data model, right? We built a data model. We have fact and dim tables, fact order for order level analytics, fact order items for product analysis, and fact reviews with AI powered sentiment analysis, right? So going ahead, we are going to aggregate all of these into gold layer for our dashboarding insights. So let's do a quick recap of the things we've completed so far. So we've seen that our orders are now streaming into this bronze table. We've also done a one-time load of the historical orders into this live orders table. Yeah. We've done an ingestion of the dim tables, which is your customer, restaurants, and menu items in the silver layer. We have also created fact orders, fact order items, and fact reviews using Spark Declarative Pipeline, right? So now we will go ahead and start with creating all of the materialized views in the gold layer. So gold is our consumption layer, basically pre-aggregated tables designed for specific analytics use cases, and we'll be creating three tables. Yeah. So we'll be creating a daily sales summary, a customer 360 profile. Basically, for one customer, it should be able to tell you everything, right? That's the idea. And restaurant review aggregation, basically analyzing customer reviews, sentiments, whether they like the food, what kind of issues are customer facing, and so on, right? And these are going to power the restaurant chain analytics. Yeah. So let me quickly walk you through what exactly are the tables that we are going to create. So let's look at the first one, and this is your D sales summary, which is your daily sales summary. And basically, by every order date, by a particular date, we are going to calculate all of these features, right? Or all of these metrics, which is for a particular day, what is the total number of orders, what is the total revenue, average order value, unique customers, unique restaurants from which order came, what were the dine-in orders, takeaway orders, and delivery orders, right? So let's go ahead and create a new pipeline, and this is going to be an ETL pipeline. We are going to name this pipeline transform gold, and we are going to start with an empty file. So we are going to rename this as daily sales summary, and let's also create a notebook by this name. Yep. Let's delete all of this, and I'm going to use the same cluster that I was using earlier, and let me copy the KPIs or the metrics that we need to create, right? So let's put this over here. Yeah. And we are going to read the orders table. Yeah. So this is going to be df daily aggregation, and we are going to read spark dot read, and this is actually not spark dot read, this is going to be spark dot table, and this is going to be 02 underscore silver dot fact orders, right? The cluster is ready. Let's have a look at the columns that we have in fact orders. Yeah. So we need to group by order date. We need to group by order date, right? And then we need to count the total number of orders. So for counting the total number of orders, we just need to do a count distinct of your order ID, right? So let's go ahead and do an agg, and we do a count distinct. Okay, so we need to run an import. So from PySpark.sql dot functions import star, and this should be count distinct of your order ID column. Fact orders will be order ID, and this we should alias as total orders, right? And then we have total revenue. Total revenue should just be a sum of your total amount. Yeah. So this should be a sum of column total amount, and let's round this to decimal. Yeah, and this should be your total revenue. Similarly, we have average order value. We'll just convert this to average, and this should be average order value. Yeah, this is going to be average order value. And the next one is your unique customers. Unique customers is going to be the same as this. Count distinct column customer ID, and this is going to be aliased as your unique customers. Then we also want to find out unique restaurants. Yeah, so this is going to be restaurant ID, and this should be alias unique restaurants. Let's remove this. The next one is dine-in orders, takeaway orders, and delivery orders. Yeah, so what we are simply going to do is f dot sum, or actually what we should do count, not f, because the reason why I said f was sometimes what I do is import PySpark SQL dot functions as f, and then do f dot sum, or yeah, something like that. Yeah, so this should be count distinct, and we should place a when your column order type this is equals dine in. When this is dine in, then we simply say order ID, we simply say column order ID, right? Otherwise we simply say none, right? This makes sense. And we alias this as dine in orders, right? Now we would just do the same for takeaway and for the other one, which is your delivery orders. Yeah, so let's do this, and we simply select this as takeaway, take away, and this is going to be delivery, and this is also going to be delivery. Yeah, this is done. Now let's select, now before we do anything, right, before we do anything, let's just see how this looks like. Yeah, okay, so we have orders, total order. Let's just sort this. We have total order, total revenue, average order value, unique customers, unique restaurant, dine-in orders, and all of this, right? Perfect, this makes sense. Let's do a final select just to make sure that we are always selecting the relevant columns. So we'll select order date, and then your total orders, total revenue, average order value, your unique customers, and then your unique restaurant, dine-in orders, takeaway orders, and delivery orders, right? Let's run this for one final time. Okay, so this works perfectly fine. Now let's put this into the declarative pipeline. Yeah. Okay, so now we are going to move all of our code to the Spark declarative pipeline. And first of all, let's move the imports. We'll need another import, which is your PySpark import pipelines as DP. And this time we are going to name this function as D sales summary. Let's copy all of the code from here and we put it here. We'll fix the indentation. Let's do a return and this should be good. Now a very important point to note is that this time we are going to create a materialize view instead of a table. Yeah, so basically earlier we were creating streaming tables and these are good for exactly once semantics and append only flow. Yeah, so these are really good for your event streams, CDC or IoT data, but materialized views are really good for dimensions and aggregations where we are doing aggregations, right? And somewhere where we want the results of a query to be pre-computed, cached and automatically kept up to date, right, as the source keeps on changing. And a very important point I want to show is from this documentation is that Spark declarative pipelines provides incremental processing engine for materialized views, right? So to use it, you need to write your transformation logic with batch semantics, right? And the engine will process only new data and changes in the data sources, right? So this is excellent. Yeah. So now for that reason, we are just going to say dp dot read instead of read stream. Yeah, so this time let's put all of our names over here. The name is going to be 03 gold.d sales summary. We are going to partition this. The partition column is going to be order date, and the table properties, this is going to be your quality equals gold. Yeah, now let's go ahead and run this pipeline and see how this works. Let me also change this to gold, although it wouldn't make a difference because I have specified gold over here already, right? Let's do a dry run quickly. So the dry run is perfectly fine. Now let's go ahead and run the pipeline. Okay, so we see that this has completed. We have 182 records and the output should look like what we've already seen, and it indeed looks like what we've already seen earlier in the notebook. And let me open the catalog explorer. This is gold and there you go, you have your D sales summary. Yeah, so the table properties we put in here is available over here as one of the properties. So now we've created our sales summary, our first gold table, which is the sales summary. Yeah, next up, we are going to create restaurant reviews. Yeah, and this is going to aggregate your reviews, sentiments, and ratings by restaurant. Yeah, and this is also going to power the review insights dashboard, which we are going to use going ahead. Yeah, it is basically going to show which locations have happy customers, how many positive, negative reviews vary over time, their trends, and all of that. Yeah. So let me first show you what exactly are the metrics that we are going to create. Yeah. So let's first create a new notebook. And this is going to be D underscore restaurant reviews. Let's also make sure that the cluster is running. And these are all of the metrics, right? So for every restaurant, we are going to store the restaurant name, the city, total reviews, average rating, your rating count, the number of times you have got a rating of 5, 4, 3, 2, and 1. Yeah. And then sentiment positive, sentiment neutral, and sentiment negative count. Yeah. And think of this table as a table which is going to be overwritten on a daily basis, or I should say the records that have been changed, they are going to be written into the table. Yeah. So for example, let's say a restaurant had 100 reviews and tomorrow also it has 100 reviews, then that row is not going to be overwritten. But let's say for another restaurant it had 50 reviews, now it has 55 reviews, then that row for the restaurant is going to be overwritten with the new data. So let's go ahead and get started with our code, and let's write the imports from PySpark.sql.functions import star. Let's run this, and we are going to read the fact reviews table. Yeah. So this is going to be your, so first of all, let's compute the review stats. Yeah. And the stats are basically these numbers that can be computed very easily, right? These are all numbers. So this is going to be review stats, and we'll read spark.table. This is going to be 02 silver dot fact reviews. Yeah. And this time we are going to do a group by restaurant ID, and we are going to aggregate. Yeah, we are going to aggregate and create all of these metrics. Yeah. So for total reviews, this is going to be the count distinct. And actually, let me just open up all of the columns over here, which is your fact reviews. And this is going to be count distinct of review ID, and let me alias this as total reviews. Yeah, the average rating is going to be average. So this has already provided me with this value, and let's also round this number to 2 decimal digits. Right now we are going to compute how many times has this restaurant got a rating of 5. Yeah. So for this one we are going to use sum f dot, actually not f dot when, just when column rating equals 5, then 1, otherwise 0, and that is correct. And this is going to be your alias as rating 5 count, and similarly 4 count, 3 count, 2 count, and 1 count. Right. So I hope this makes sense. Basically, we are taking up rows wherever there is a rating equals 5, we are marking that as 1, and wherever there is a rating other than 5, we are marking it, putting the value 0, and then we are summing up the all of the rows, right? And then after summing up, we create the rating 5 count. Yeah, that makes, I hope that makes sense. Now we are going to compute how many times have we got a positive sentiment, neutral, and a negative sentiment. Yeah, and this is also going to use the similar approach. When column sentiment is going to be positive, then we put 1, otherwise 0, and this is going to be my sentiment positive count. And similarly we are going to do it for neutral and negative count. So these are all of the stats that we need for creating our restaurant reviews table. Yeah. So let's go ahead and then do a display on this table. Okay, the results are here, and we see that restaurant ID, total reviews, average rating, and this some case. Why didn't the alias work over here? That should have worked. Okay, I should put it over here. After the sum, there should be an alias, and probably that's the reason why it didn't work. Now let's go ahead and run this, and there you go. So okay, the same mistake. but I hope you get the idea, right? Yeah. So now that we've created all of the metrics, the only thing that is remaining now is all of this is done. We need to add the restaurant name and the city. And where is this information present? So this information is present in your dim table, the dim restaurants table. Yeah. We have the name and the city. So let's go ahead and do left join, a left join of the restaurants with this review stats. The reason why I'm doing a left join is because your restaurant, it is a kind of a master table which has a list of all the restaurants, right? So some will have all of this data, others won't have it, and that is completely fine. Yeah. But I want to have a list of all of the restaurant or restaurant reviews. Yeah. So this is going to be restaurant reviews, and we are going to read in the restaurant table. And for reading in the restaurant table, let's first do df restaurant. This is going to be spark.table 0 to silver dot dim restaurants. And we do a restaurant dot join. And this join is going to be with your review stats on the restaurant ID. And this is going to be a left join. Now let's quickly do a display and see what are the items that we get out of it. So we've gotten everything, right? We've gotten the name, city, country, opening date, phone number, and then all of the other columns that were related to the reviews. So let's quickly select the column that we need. And these are going to be your restaurant ID. This is going to be your restaurant, your name, aliased as restaurant name, and then your city, and then all of the other columns coming over here. But there's an important thing that we need to do, and that is we need to coalesce it with 0. The reason why we want to do this is because when we are doing a left join, there are going to be some restaurants which are not going to have reviews, and we simply put a 0 or a default number for them. Yeah. So average rating, this is going to be like this. And let me also cast this number. Okay, let's not do the casting right now. Let's do a coalesce of all the other columns, which is your rating, 5 count, 4 count, 3 count, 2 count, and 1 count. And we also do this for the other sentiment columns. Yeah. So now this is done and this looks fine. Let's go ahead and run this finally. So we see now what we've wanted. We have the restaurant name, the city, and then your total reviews, average rating, rating count, and all of this, right? So now we've created the restaurant reviews table. Now let's move all of this code to Spark Declarative Pipeline. I'm going to create a new file, and this is going to be d underscore restaurant reviews, and we'll start moving in our code from here. Let's move this from PySpark import pipelines dp. This is going to be named the restaurant reviews. Let's paste all of our code from here. First we generate the stats table, because this is again going to be a materialized view. Let's use dp.read, and this is going to be removed. Let's place the other part over here, which is this one. This is also going to be dp.read, and we are going to return this data frame, the restaurant reviews. Yeah. And this materialize view, the name is simply going to be 03 gold and materialize and restaurant review. Yeah. The table properties is going to be quality and gold. So this looks good. Let's go ahead and quickly do a dry run. This seems to run fine. We are good to now kick off a run of this pipeline. Okay, so we see 5 outputs over here, and let's go and have a look. The restaurant reviews, we have 5 restaurants, and that is why we see 5 rows over here. And this basically contains all of the details, which is your total reviews, the average rating, all of these counts, your sentiment count. So we've successfully created our restaurant review table. Okay, now we'll be creating the final table, final goal table, which is customer 360. And this is a very important, very meaningful table, something that almost every organization should have. Yeah. So it basically provides a single view of each customer with all their metrics. So let's say if you are an e-commerce company, you would store things like how many orders have a customer made in the last 30 days, 60 days, 90 days, how many complaints have a customer made in the last 30, 60, 90 days, right? How many orders have a customer placed in their whole lifetime, right? What is their lifetime spend value, right? So basically one row to basically describe the entire profile of a customer. Yeah. So this enables things like personalization, loyalty program, churn analysis. Yeah. So we are going to create these columns or these attributes, and let me create another notebook, customer 360, and let's first separate this out, right? So we are going to separate this out in what kind of statistics are they, right? So email, city, and all of this, these are coming from the customer dimension table. Yeah. Even join date is going to come from your customer dimension table. So this is going to come from customer dim table. Loyalty tier, total orders, lifetime spend, average order value, last order date, right? Last order date, this is also going to come from your orders. These are basically order statistics. Let me write this as order stats. These are your review statistics. These are some favorite metrics. And then finally there's another one which is at is at risk. I think removed we removed this. We are not going to calculate this. So we are only going to have these metrics to build the profile of a user, right? So first of all, what are the things that we need? For this one, we need the customer dim table. For this one, we need the fact orders table. Yeah. For this one, we need the fact reviews table. And for this one, we need the fact order items table, right? So then only we'll be able to figure out which is the item which is the favorite, and the item, the restaurant that was used to place most number of orders. So let's go ahead and start to build this piece by piece. So first of all, we're going to create order stats, and this is simply going to be, it is going to read your orders, right? So This is going to be df orders is spark dot table and 02 silver dot fact orders, right? So this is going to be df orders, and we are going to group by the customer ID and aggregate and create columns such as, let's say, total order. Let me first from PySpark.sql.functions import star, and we'll be using the same cluster. So this, for calculating the total orders, I should just do a count distinct of order ID, and this should give me total orders for your total amount. Yeah, for total amount, the column that I should use is total amount over here, and let's do a sum of total amount, and this is going to be your lifetime spend. Average order value is simply going to be this wrapped in, actually not wrapped in, but instead of sum we use average, and this is going to be average order value, right? Let's also round this to 2 decimal places to keep it neat. And then you have your last order date. Last order date is simply going to be max of order date, and this is going to be aliased as last order date, right? So we have calculated these 4 values, right? Now in order to calculate loyalty tier, the simple formula that we are going to use is, actually we are going to use after this, after the aggregation is done, we are going to create a column with where your loyalty tier is going to simply follow this kind of a rule. When your lifetime spend is greater than equal to something, let's say 50,000, or let's keep this number small because we don't have a lot of orders. Yeah, we have around 8,000 orders, so per customer this 50,000 number might be very big. So let's keep this to be greater than equal to 5,000, then it will be platinum. Let this be 2,000, then it is going to be gold, and this column is going to be greater than 1,000, then it's going to be silver, otherwise it's going to be bronze, and this is going to be your loyalty tier. Yeah, so these are your order stats. Let's go ahead and display this. So we see that per customer we see the total number of orders, lifetime spend, average order value, last order date, and the loyalty tier, which is gold, silver, and platinum. Yeah, so we've created the first part, which is your order stats. Now let's create the review stats. For the review stats, we have to read the reviews table, and this is going to be spark.table 02 silver dot fact reviews. And what we need to create essentially is per customer, the average rating given by them, and the total number of reviews. Yeah, so we just do a group by, which is review stats equal df reviews dot group by customer ID, and then we do an aggregation. This aggregation should give me the total reviews. So the total reviews is going to come through count distinct review ID, and this is going to be alias as total reviews, and the next one is your average ratings given. So this is going to be, let's round it off, and this is going to be rating, and we alias this as average rating given, just to make sure that these are the right columns. Fact reviews does have review ID and rating. So let's display this. Perfect. So now we have the total number of reviews and the average rating given per customer. So next up, let's create another important and interesting metric, which is favorite restaurant of the customer. And the way we are defining favorite restaurant is simply the restaurant to which maximum orders were placed by a customer. And we can use this fact order table. We have the customer ID over here and the restaurant ID over here, right? So let's go ahead and read this table. Actually, we've already read in this table over here, right? So now do favorite restaurant, and this is going to be orders, and let's group by customer ID and restaurant ID, and we do an aggregation by the order count. Yeah, and let's also order this by we order this by customer ID and order count, and let's display this. Okay, so we see that for this customer, this person has placed two orders from each of these restaurants. So we can simply just pick up any one of it, right? For this customer, this person has placed maximum number of orders from this restaurant in Dubai, which is 5 orders, right? So what we are going to do now is simply we are going to use row number. Yeah, we are going to rank, we are going to partition by the customer ID, and we are going to rank by the order count in descending order. So the one which has the highest number of orders goes on top, and then we are going to select that restaurant. Yeah, so let's go ahead and create a column called with column row number, and this is going to be row number dot over. Okay, perfect. uh, and then we are going to order by order count descending, and we are also going to filter by column where rn equals 1, right? We need to import this window, which is from pyspark.sql.window import window. So this is fine right now, and let's go ahead and have a look right now. So now we see that per restaurant, you see that this customer liked this restaurant in Dubai where he had placed 5 orders. Now we see only one row with respect to this customer. Yeah. So we are simply going to remove this order by, and let me just select the customer ID and the restaurant ID. Later on, we are going to join this with the dim restaurant table and get the actual restaurant name. Yeah, but this should work completely fine. Now let's go ahead and create the final metric, which is favorite item. What is the favorite item of each customer? And we have item level details in fact order items table, which is your item ID and item name. But we don't have customer ID to be able to link which customer has placed an order for this item. But if we look at fact order, we do have order ID and your customer ID. Yeah. So in order to be able to link that these set of items were placed on order by this customer, we need to join fact orders and fact order item on order ID. Yeah. Now this is a classic example of data modeling where if you would have put customer ID in fact order items, you wouldn't need to join two large fact tables, right? And these tables can be very large in several organizations, right? So this has been purposely designed this way to show you the importance of doing data modeling the right way, right? Doing data modeling in a way such that it suits your analytical needs. Yeah. So for now, we are going to simply read in fact order items, and this is going to be spark.table. This is going to be 02 silver dot fact order items, and this will be your favorite item. df order, let's join it with fact order items, and the join is going to be on order id, and it's going to be an inner join which we don't need to specify, and we're going to group by customer id and the item name, and let's aggregate and find the quantity, right? So we have this column called quantity. We basically want to sum the quantity to understand how many number of items were placed for orders, right? So this is going to be item quantity, and let's do a quick order by. This order by is going to be your customer id, item name, and descending of item quantity. So here we see that this customer who has this id customer 10,000, probably the, yeah, so this customer who has this id 10,000, the item that he likes the most is this kulfi over here. And if you look at this customer 10,001, this guy likes garlic naan. I like it too. So this is where we can now run a window function, and this is going to be okay, perfect. So this is going to be the same. It's very similar to what we've already done. We are going to do a row number over partition by customer id. So we are going to partition by customer id and then order by the item quantity. The item quantity which is the highest goes at the top because we are ordering it from the highest to the lowest, and that is going to get a row number of 1. So the reason why we do a row number and not a rank or a dense rank is because, let's say two items have the same quantities, we only want to pick up one item, right? So if the second item has the same quantity, it is automatically going to be numbered number 2 instead of 1 in rank and dense rank. Yeah. So we are going to filter by the row number over here, and we are simply going to select, yeah, we are simply going to select your customer id and the item name, and let's actually name this as favorite item. Yeah, let's run this. Okay, there seems to be some issue. Okay, we didn't put in the filter condition. Perfect. So we see for customer number 10,000, kulfi was the favorite item, and customer number 10,001, garlic naan was the favorite item. So this works as expected. Now let's merge all of the stats that we've created, right? And the spine, the base is going to be our customer table, right? Because we want to generate a profile for all of our customers. Yeah. So let's name this data frame as C360. This is going to be your DF customers. And I realize I have not yet read in the customers data. So this is going to be spark.table and 02silver.dim customers. This will be dim customers, and we keep on doing a left join with order stats, with review stats, favorite restaurant, and then the favorite item, right? So now once this is done, we are going to select the relevant columns that we need. Yeah. So the relevant column that we need are, let's copy this quickly and we paste this here. Oh, let's just this be as Python code, and let's also comment this out. Yeah, so this is going to be your customer id is going to come from the customer table itself, the dim customer table, and then we need the customer name. The customer name should be in your dim customer table. So let me put this like this, dot alias customer name, and then we have your email. Email is going to be as it is. Then you have your city, and finally you have your phone. Do we also have joined it? Yeah, we also have joined it. Sorry, we don't have phone, we have joined it. Yeah, so that's the first part. Now we need the total order, lifetime spend, average order value, and the last order date. So let's calculate the, not calculate, but put in the order stats over here. So this is going to be, let's coalesce this, and this is going to be the total orders column, total orders, and we are going to use 0 if the customer has not placed any order, and this is going to be aliased as again total orders, and we would do similarly for the other ones as well. Lifetime spend, average order value, last order date. So for the last order date, what we are going to do is, if it is null, we are going to let it remain as null. Yeah, so we just put last order date as it is, and finally what is the other one, just total orders, lifetime spend, average order value, last order date, and the last one is your loyalty tier. Yeah, so the loyalty tier, I believe we already calculated here, so we just take this as it is, loyalty tier. Now let's calculate, let's add in the review stats. The review stats is going to be like this, which is your average rating given, and then your total reviews. This one is also going to be coalesce. This is going to be column, and this is going to be lit 0 dot alias, average rating given, and let's also convert this to decimal dot cast decimal 10,2. The reason why we are doing this is because we want to avoid all kind of uh, floating point precision issues. Yeah, so to keep this consistent all across, we will just use decimal, and we will also use decimal for all of the others, which is your total orders. Total orders is not needed, but lifetime spend and average order value. Yeah, then finally let's add the favorite items column, which is your restaurant ID and the favorite item. Actually, if we want, I believe I told you that we would calculate the name from the restaurant ID afterward, but I think this might be the best place to do it here itself. For favorite restaurant, let's just do a join with your dim restaurant. So df restaurants is dim restaurants, and then we do a join with df restaurants on restaurant ID, and this is going to be your inner join, and let's see the name instead of the restaurant ID. Okay, there is an issue. I think I've put the wrong column name, so this is just the name over here, right? Perfect. So now this looks good, and let's quickly rename Let's quickly rename this as restaurant name. Restaurant name. Yeah. Let's run this again. Okay, this looks good. Now I'm going to place restaurant name over here instead. Yeah. And one of the last columns, which I said that we are not calculating, is this one, is at risk, no order for 90 days. But instead of this, we are going to calculate another column, which is VIP. Yeah, is VIP. And is VIP basically means that your lifetime spend is greater than equal to 5,000. Yeah. So let's quickly calculate this last column, and this is going to be when column lifetime spend is greater than equal to 5,000, then it is true, otherwise it is false, and this is going to be is VIP. Okay, now let's run this. You're going to do a display of your customer 360, and there we go. So we have our customer name, email, city, the joining date, your loyalty tiers, total orders, lifetime spend, average order value, what was the last order date, what was the average ratings given, right? And then we have the total reviews, what is the favorite restaurant name, the favorite item, and whether this person is a VIP. Yeah, perfect. So now we have created our final table, which is the customer 360. Now the only thing that we need to do is move this code for customer 360 into the Spark declarative pipeline. I'm going to create a file again for customer 360, and there is actually going to be lots of code that we need to move, so we'll be a little careful. Let's copy this, and this is going to be again from PySpark import pipelines as dp, and this is going to be named customer 360. Yeah, let's keep this consistent and also rename this to customer 360. Yeah, so now let's actually put first all of the tables, right? First we'll put order stats, which is this one. We created the order stats, and let's replace this with dp.read. Now once order stat was created, we have the review stats. This is again going to be dp.read. Review stats has been merged. Now we are putting in the favorite restaurants per customer, and for this one we are again going to do dp.read. Let's move this over here, and once this is done, we are going to move to the favorite item, which was this part. Let's do the indentation correctly, and let's also replace this with dp.read. Let's remove this, and finally we do the joining, which is going to generate our master 360 customer 360 table. Yeah, and let's return this customer 360 table. Yeah, okay, so we are going to again replace this with dp.read, and let's quickly check if there are any errors. Okay, this looks fine, and again this is also going to be a materialized view, and we are going to name this 03 gold dot customer 360, and table properties is going to be similar to what we've done earlier, which is quality is gold, right? So let's go ahead and do a dry run now. The dry run seems to work fine. So let's go ahead and run the pipeline now, and we should see a new table in the gold layer. Okay, so we see for customer 360 we have 500 rows as the output, and let's run this now. So 03 gold, and this is going to be your D customers 360. Let's run this. Let's also click over here and see what happened. Perfect. So now we have completed all of the three gold layer tables. Our gold layer is ready. Daily sales summaries, customer 360 profile, restaurant review metrics, all are pre-computed and optimized. And in the next part, we are going to orchestrate all of this together with Databricks workflows. Now, an important point to note is we are going to use daily sales summaries and restaurant review for building the dashboard, but not customer 360. But this was an important table to understand how customer profiles are made in the industry. Now we are going to create a workflow which is going to contain right from ingestion, streaming ingestion, until the creation of the bronze, silver, and the gold layers. Yeah. So let's go ahead and go to jobs and pipelines, and we click on job, and then this is going to be workflow daily master, right? So we are going to add another task type, which is your, so let's actually go back once. Yeah, so there are a lot of pipelines that we created. This was the one that we were working on right now. Pipeline transformation gold, pipeline transformation silver for creating our data model, which is the fact and the dim table. And then we have pipeline bronze, which basically ingest all of the data from your SQL server into the bronze layer. Pipeline silver, which ingest all of the data from your SQL server into the silver layer as dim tables, which is restaurants, menu items, and customers. And then we have the streaming ingestion over here, right? So right now what we want to do is we want to leave this aside. We want to run this on demand as and when needed. What we want to do is we want to take this up, which is ingestion from Event Hub, place it as at the first stage, and then whenever we have data, we are then going to run the silver transformation and the gold transformation, right? So let's pick this. Another type is going to be a pipeline. This pipeline is your Event Hub pipeline, and let us keep the name just the same, pipeline ingestion Event Hub. And we are going to create this task. Now once this task is created, we need another pipeline. This pipeline is your silver transformation, and we'll again keep the name same, pipeline transformation silver. This depends on your ingestion from Event Hub, and only if it's successful, then the silver pipeline is going to run. We create this task, and finally we create the gold task. Yeah, so this is going to be gold, and this is going to be the gold pipeline over here. And again, this is dependent on silver as expected. So now if we run this, we should not get any outputs. Yeah, but let's go ahead and run our pipeline, which is going to be synthetic orders over here. Let's start this and let's run it for some time. Let it just push a few orders to Event Hub, and we run this pipeline right now. Yeah, so we click on view run. I'll pause this for now so that we don't push a lot of events to Event Hub, right? It would take all of the events that we've pushed and only those events should be processed. Yeah. So this ingestion has completed and we see 13 orders. So basically there were 13 orders that were pushed from here. Let's have a quick look. So there were 13 orders as expected. The silver pipeline has also succeeded. So we see that fact orders, this has processed 13 orders, the orders that we got from Event Hub, and that has resulted in 35 order items. And because there were no reviews, this remains empty. The output records remains empty. Yeah. And let's go to the code layer to see what's happening. Okay, so this is still in progress. So we see that the gold pipeline has also been computed, right? An important thing to note is that the sales summary, the incrementalization was incremental. What means is that it specifically took up those records. It specifically took up all the order dates that have changed and only processed those partitions. That is why you see that the incrementalization is incremental. Now for restaurant reviews, because we did not push any review, the incrementalization is no change, nothing changed, right? For this specific table. Now a very important thing to understand is why did Spark declarative pipeline do a full recompute for the customer 360, right? While it completely worked fine for sales summary and restaurant reviews. So this is a very important query that you should keep handy. And basically what we look at is the event logs to understand what goes behind the scene. What is the planning information before the pipeline was actually run? Yeah. So we see this is for the sales summary. This one is for, yeah, this one is for customer 360. So let's copy this, put this in a JSON formatter. And what we see over here is incremental plan rejected by the cost model. And because of this, the maintenance type is a complete recompute. Complete recompute is chosen and there is some cost, the cost that we were talking about it, right? And we've seen that Spark basically clears a lot of plans and the cost model is the one which finally decides which plan is going to be executed on the cluster. Yeah. So a food for thought, and you should try this out. So this customer 360 table over here, this is right now not partitioned by any column, right? So let's say you partition it by customer ID, and when you stream orders, those orders are going to contain certain customer IDs, right? So after partitioning it, you need to see if only those customer IDs were updated, because the profile is only going to change for those customer IDs, right? All of the profiles for the other customers are going to remain the same. Yeah. So do this as a homework and check what would happen if you partition by customer ID, then you stream in records and they are going to contain certain customer IDs. Does your customer 360 table get updated for those certain records, similar to what you see for the deal sales summary, the incremental mode of computation over here? Yeah. So now our orchestration is complete, it is in place. Streaming ingestion can run continuously, and our silver layer and gold layer transformations run together in a master daily workflow. Yeah. So next up, we are going to build up our restaurant chain performance and review inside dashboard. So let's do a quick recap of all of the things that we've completed so far. So our bronze layer is up and ready. Our silver layer is up and ready. We built our data model, right? We built our data model, which is your fact orders. fact order items, and fact reviews, all the fact tables. And we've earlier seen that we've already ingested the dim tables, right? And finally, we've created the gold layer aggregated tables, which is your D sales summary over here, right? Basically, on a daily level, on an order date level, we have created summary statistics related to our sales, orders, and all of it, right? And then we have a very unique table which is called Customer 360, which gives us a complete profile about a customer. For example, how much have we earned from that customer, how many orders this the customer place, yeah. And finally, we have the restaurant review table, which is going to give us a summary of the reviews, the kind of reviews that a customer, that a restaurant has got over time, right? And this table is going to be overwritten every time, right? So that is the way it's been created. But what you can also do is create a new column called snapshot date, and then keep appending data for that particular snapshot date, right? So you can partition by snapshot date and then keep appending. That's one approach. Or you could also write something like a merge into statement, right? Merge into statement, and using the restaurant ID as the key that is going to be used for merging, and only those restaurants are going to be updated which have new reviews or new data for reviews, right? For our case, we are going to do the same, right? So our Spark declarative pipeline is going to figure out the new incremental data, and then only those restaurants or only those rows are going to be updated for which new data has come in, right? So we finally created all our goat labels. Now we are going to create the dashboards. Yeah. So let's get started. So now we are going to come to another interesting part of the project, and this time we are going to build two dashboards, and there's no Tableau or Power BI installed or needed. We are going to keep everything within the Databricks ecosystem. So we are going to use Databricks AI BI dashboards, right? So there is going to be two set of dashboards. The first one is your restaurant chain performance dashboard, right? So the restaurant owner is wanting to look at how the overall chain is performing, right? How the overall set of restaurants are performing together. So that is why we have this set of metrics, which is your total orders, total revenue, average order value, how the peak hour analysis looks like, right? So I'm going to show you how these dashboards are going to look like, how the end state is going to look like, so that you can get more idea. Yeah. So that's the first one, and we can filter by a particular date range so that we can understand how, let's say, the total orders were or how the revenue were within those particular date range. And the second one, and indeed this is a very important one, to hear out what customers feel about the food and the product, right? So we can filter by restaurant name, and we'll be able to have a look at different kind of metrics, right? How has the review volume been over time? What is the average rating, right? What has been the positive, negative, and neutral reviews? Yeah. And we'll also see the trend over time for these kind of reviews. And most importantly, we want to understand what kind of issues have the customer face. Is it more like a delivery problem? Is it a portion problem? Is it a pricing problem? So all of that is going to be displayed on this dashboard. Yeah. So the first dashboard we are going to build is your chain performance dashboard. And as you see over here, there are several metrics relating from orders, revenue, active customers, how your daily sales has been, your best selling items, peak hour analysis, basically showing on which of the hours is the demand the highest. And then you have your revenue by order type. Is it delivery? Is it dine in? And or is it takeaway, right? Right? Which order type is getting me the most amount of revenue? And then finally, revenue by the food category, right? Which category of food is selling the most? And the next one is your customer review dashboard. Here we basically said see that per restaurant. So basically this is for all restaurant that you see over here, but we are going to have the option to filter by restaurants, and you can select a restaurant and we'll see total reviews, what has the average rating been, how is the positive, negative, and neutral reviews, what is the total number of it, right? And then we also see the distribution over time, how many 1 stars, 2 stars, and 5 stars have these restaurants got, right? How are the issues, what are the issues that the customers have been facing? Is it like delivery quality, food quality, and lastly some of the most recent positive and negative reviews, right? So I hope you are as excited as me, and now let's go ahead and start building the dashboard. So let's start building the first dashboard. Yeah, and the first metric that we are going to create is going to be total orders, right? And the data set that we are going to use for this one is your goal table, and this is going to come from the sale summary because we've already aggregated all of this information over here, right? So we go over here, this is going to be the sales summary, and this is just going to be a number, right? So let's take up total orders. Now remember that this is by order date, right? Per order date, you're going to have total orders, right? So that is why we need to sum all of the orders, total orders, in order to get the total value over here, right? So that is why we put a sum, and this is going to be total orders. Yeah. Similarly, let's create all of the other metrics, and this is going to be your total revenue. Let's change this, total revenue. The next one is going to be active customers, and the definition of active customers is basically the customers who have placed an order, right? So now you see that we don't find this information in the details summary table. We don't have customer ID, right? So where can we find this information? We can find this information in the fact order table. Yeah, so let's go ahead and pull up the fact orders table. Yeah, now let's change this fact order, and this is simply going to be my customer ID, and this will be count distinct. Yeah, so this is active customers. Now we need average order value, right? So let's quickly see where exactly can I use, which table can I use, right? So we cannot use the sales summary because we don't have information about the total. Okay, we do have, we cannot do a division over here, right? I do have total revenue, but I cannot just do an average because that will be the incorrect value, right? So let me quickly check fact orders, and in fact orders I have, because this is at an order level, we can simply sum the total amount, sorry, not sum, but do an average over here, right? So this is going to be your AOV, which is average order value. And lastly, we are going to have unique customers, right? Unique customers. And for this one, we basically want to understand what are the total number of customers in our platform. And for this one, let's use the dim customer table. Let's go ahead and use this, and let's place a dim customer over here. This is going to be your customer ID, count distinct customer ID, perfect. And your unique customer is 500 again. So basically what this means is, out of the 500 customers that we have in total, all of them have placed an order at least one, right? Because this is coming from fact orders, this is coming from dim customer. Yeah, so let's just format all of this a little bit. Let's place this over here, this over here. Let's also place a date filter, right? So that we can look at these metrics over time. So let me name this as date range. And before we do this, right, before we put this over here, put the date range over here, we need to make the data set that we are using underlying the metrics over here, they need to be able to filter the data using date parameters, right? So basically we are going to put where join date between, and let's add a parameter over here. This parameter is going to be your date range dot min and date range dot max. So in order to make it a parameter, we just need to specify this this symbol over here, and then we put the date range. When we put the minimum, it is going to take up the first value that we specify over here, the first, which is the from, right? So let me set this to a particular date, both start and end dates, right? And let's go ahead and run this. So it basically filtered all of the values between this date range. Yeah, let's do it for all of the other ones. The name of the column is just going to change. This is going to be order date, and let's also change this to a date range, and let's put a date range quickly. Yeah, let's run this now, and similarly for the last one as well. Actually, detail summary, we are also going to use order date, and this is just going to remain the same as fact orders. Okay, this works. Now when we select this, we basically want to add all of those parameters over here, and we select a date range picker, and we add all of the parameters. So which fields are the one that we want to use for parameterization? It is the date range field, right? So let's also do it for fact orders. Let's also do it for dim customers. Yeah, so now you will notice that whenever I change a date over here, all the numbers are going to get adjusted, right? So you see that the numbers have got adjusted. So that is how parameters are going to work, and that is how we are going to use date ranges over here. Now let's create the daily sales and average order value chart, and for this one we are again going to use the sales summary. This is going to be a line chart. Your x-axis is going to be order date, and this is going to be daily, not monthly, right? Let's name this as order date, and the y-axis is going to be your number one is going to be total orders. Yeah, and number two, okay, this is not going to be a sum, right? Because we've already aggregated by order date, and that is what is our x-axis, right? So this is going to be none, and this is going to be total orders. Yeah, and let's add another one, which is your average order value per day. So this is again going to be none, and this will be average order value. Yeah, let's also quickly change the colors, and this one is going to be this. Yeah, so total orders is total orders, and this one is average order value. Let's Is there a way I can, if I add labels? Okay, this becomes very cluttered, so let's not do that. Yeah, so this is how our daily sales is going to look like. So for example, on October 20th, our total orders were 33 and the average order value was 171. The next one is top 10 selling items, right? And where do we have item level data? The item level data is present in fact order items. So let's quickly run this, and here we have the item name, and to understand how many times what is sold, we take up the quantity column, right? So let's just do a item name and sum of the quantity as total quantity sold, and we'll do a group by item name, order by total quantity sold descending, and we'll do a limit 10, right? But now a very important thing to understand is we want to do this within a date range, right? So this is going to be where order date between date range dot min and date range dot max, right? And let's change this to a date range, and we'll select the range of dates over here. Yeah, let's run this query now. Okay, So this has been modified according to the dates that we selected. Now let's get back and let me also name this. Let's rename this as top 10 selling items, and this is going to be a new chart over here. And let me quickly add, let's quickly add this one over here. So the top selling items has to be within a date range, so that is why we add this filter over here. And this is going to come from top 10 selling items. It will be a bar chart. The y-axis is going to be the item name, and the x-axis is going to be total quantity sold, right? So we are going to remove the sum because we already did a sum in the query itself, right? And let me delete this. Yeah, so we already did a sum, and let's quickly change the color as well. So this is total quantity sold, and this is your item. So here we've created a chart for figuring out which is the top 10 most sold item, right? So let's add that title over here, top 10 selling item. Now the next one that we want to build is the order volume by the day of the week, right? So for this one, we are going to use fact orders, and the x-axis is going to be your day of week, which we already have over here. And the order volume, for the order volume, we are simply going to select your order ID over here. Where is the order ID? And this is going to be a count distinct, right? So this will be your total orders, and this is your day of week, right? And let's also put a label over here so that we are able to quickly understand how many orders have been placed on a particular weekday. And the title is going to be order volume by day of week, right? Next up, we want to do a peak hour analysis, right? So basically, we want to understand for each of the days on which hours is the demand the most and the lowest, right? So we'll use a heat map for this. Let's place the heat map over here, and let's use fact orders table because it has the order hour and it also has the date and the day of the week, right? So we are going to use a heat map. On my x-axis we are going to have the day of the week, right? Actually, not on the x-axis. Let's put this on the y-axis. So on the y-axis we have the day of the week, and on the x-axis let's put the order hour, right? Now in order to decide the color, this is simply going to be by the count distinct of your order ID, right? So count distinct of order ID, and let's use the color as your red. Let's check the other one. Yeah, this looks a lot better. So we are going to use this. So we see that the orders on Wednesday in order hour 13, which is around lunchtime, there is a high influx of orders, right? And similarly on Tuesday, during lunchtime, which is at around 2 p.m., there is a high influx of orders, right? And take this with a pinch of salt because this has been generated using synthetic data, right? So let's beautify this a little bit in terms of what's written over here, and this is going to be order hour, right? This is going to be day of week, yeah. And finally this is going to be your order, or maybe this is going to be total order, right? I am going to remove this, right? But yeah, just know that you can turn on the labels over here, yeah. Finally, let's build the last two chart, which is revenue by order type. So let me put another chart over here, revenue by order type. I believe we do have order type in fact orders. So this is going to be a bar chart. On the y-axis we are going to have your order type, and on the x-axis we are going to have revenue, which is your total amount, and this is going to be a sum because we have not already pre-aggregated this, right? So this is going to be your total revenue, and let me us quickly write this title over here: revenue by order type. Yeah, let's also place the label over here, and this is going to be total revenue, and this is your order type. Yeah, and the last one is what is my revenue by food category. Let's quickly put this over here. By food category, we have category level details in fact order items. So we are going to select fact order items. Let's put this over here. Let's quickly copy this so that we are able to do a filter where order range between min and max, and this is going to be a date range. This, let's quickly select a particular date range. Let's run this. Okay, this works fine. So we are going to make this a pie chart this time, and this is going to be your color. Your color is going to be decided by the category. Where exactly? Okay, I was looking at fact order. This should be fact order items. This should be the color should be decided by the category, and the angle should be decided by the revenue. So let's sum the subtotal over here. Yeah, we sum the subtotal, and this is how it looks. Yeah, so sum subtotal is going to be called total revenue, and category is just going to be category, but let me just put it in caps, and let's put a title over here which is revenue by food category. Okay, so we have built our first dashboard which looks really nice, and let me check if we've put parameters for all of the data sets we are using. So we are using fact order items. Let's also put a parameter for that, right? And let's go ahead and publish this dashboard. So we've published this dashboard here, and this looks amazing. Yeah, let's also try changing the dates. Let's put this over here, and let's put 10th of Jan, and we see that the numbers have changed now. Yeah, as expected. Perfect. Now let's move on to the review inside dashboard. So this is going to be the customer reviews dashboard, and we are going to use the fact, sorry, not fact, but the D restaurant reviews table that we created specifically for this purpose. And we see that per restaurant we have specific set of statistics, right? Which is your total reviews, average rating, count of 5, 4, 3, 2, 1 star ratings, and then your count of positive, neutral, and negative reviews, right? So this time let's go ahead and add this. We are going to create our first metric, and this is simply going to be a number. The value is going to be your total reviews, and you see that we've done a sum total review. Sum basically is going to sum all of the reviews across all of the restaurants in the chain, right? So this is basically my total reviews. Yeah, so that is why we've placed a sum, because we wanted the total number of reviews across the chain, right? But let's say now if we want to filter by a particular restaurant, yeah, we are going to use a field over here, right? So let's just select the restaurant name, right? So here you see all. If we are selecting all, it should ideally sum up all of the reviews. Yeah, and I also want to share with you that why are we using fields instead of parameters? Yeah, because earlier you've seen that we've used parameters everywhere. So parameters are basically placeholders that modify the underlying data set at runtime, right? So you've seen that we inject it in the query itself So for example, where order date between date range.min and date range.max. So this basically offers very powerful control over the query logic, right? So that is when you use a parameter. Now, field filters, on the other hand, they refer to filters on the resolved results of a data set, right? After the query has run, right? So basically, they are used for providing like very quick interactivity for already fetched data. So if I were to select this restaurant over here, it would change to 25, right? So doing it with or without a sum would yield me the same result. Yeah, you see, if I put none, I also get 25. If I put a sum, I also get 25 because there's only one row per restaurant as we have seen in our table. Yeah. So now let's go ahead and add a few other metrics over here. This is now going to be average rating, and for this one I'm going to make this average of average rating, because again, if it's for one restaurant it doesn't make a difference, but when you do it across multiple restaurants, it is basically doing an average of the already average out rating, right? So it basically takes all of this up, divides it by 5, and then gives you the final average rating when you've selected all. Yeah. And then we want to also understand in which city is this restaurant. So let's select the city itself. This is going to be none, and this is going to be the city. Yeah, let's put it like this, and then we are going to add in 3 new columns, which is, okay, let's make this smaller. Let me remove this. We are going to add in 3 new tiles over here, which is going to tell me your positive reviews, your positive review count, your neutral reviews, and finally your negative reviews. Yeah. So for this one, we also are going to take up this value, which is positive count. Yeah. And we just do a sum. Yeah. For the same reason that we've done before, we take up this one, which is neutral, and we do a sum. And for this one, we pick up the negative and we do a sum, right? And let's also color code this a little bit. This is going to be your red, this is going to be yellow, and this is going to be green. Yeah. Next up, we are going to build an interesting chart which is monitoring the trend of review sentiment over time, right? So basically monitoring how positive, negative, and neutral sentiments have been over time, right? This is very important for this kind of a business because we want to specifically see things like, for example, has there been a sudden increase, right? Has there been a sudden rise in the number of negative reviews? If there has been so, then we need to intervene and fix the root cause. Yeah. So the data set that we are going to use, it's not going to be a direct data set. We would need to write a query. Uh, so basically, we would need the sentiment and the restaurant name and also the review date, right? So number one, the sentiment is present over here. The review timestamp is also present over here because we want to monitor the sentiment over time, right? But we don't have the restaurant name over here. We do have the restaurant ID. So let's do a join between this one and your dim restaurant table, right? Now this looks fine, so we are going to put a r dot name as restaurant name, and because we want to do it over time, there has to be a date column, and this is going to be review date. And now we want to figure out the number of positive, negative, and neutral reviews over time, which is review date, for each of these restaurants specified over here, right? So let's do a count distinct, right? Case when sentiment equals positive, then order ID, right? Else null end, and this is going to be positive review count. Let's do it similarly for the negative and neutral reviews. Yeah, so this is going to be neutral and this is going to be negative. Yeah, let's do a group by of 1 comma 2 ordered by 1 comma 2. Yeah, okay, so we see that per restaurant for a set of days we are now able to understand how the positive, negative and neutral reviews have been over time. So let's go ahead and use this. We are going to create a chart. This is going to be for, okay, so let me rename this to review trend. Yeah, this is going to be your review trend. The x-axis is going to be the review date and this is going to be daily. Yeah, let's name this as date. The y-axis is going to be positive review count. Yeah, and let this be a line chart. Yeah, similarly we are also going to add negative. We are also going to add neutral. Neutral is going to be yellow, negative is going to be red, and positive is going to be green. Yeah, so this is how we see, for example, okay, let me rename this quickly. Positive review count, this one is going to be negative review count and this one is going to be neutral review count. Yeah, so we see that, for example, on this day the number of positive reviews were 3 while negative and neutral reviews were 0. Yeah, the next chart we are going to make is basically the rating distribution for each of the restaurants. So for example, how many 5 stars, 4 stars, 3 stars have a restaurant got, right? So let's first create the data set for this and we are going to use the goal table, which is your D restaurant reviews. So this table basically has the restaurant name and the rating 5, 4, 3, 2, 1 count over here. Yeah, but the way a bar chart works, right? So the way we want to build this is on the y-axis you're going to have 5 stars, 3, 5, 4, 3, 2, 1, and then on the x-axis you have the number of reviews, right? Basically the number of times the customer has given a 5-star, 4-star, and so on, right? So this table needs to be, so this is now, if I were to say this has been pivoted, you need to melt it, right? This is melted a panda specific term. You basically need to unpivot it, right? So the key or the rating label is going to be something like 5-star, 4-star, 3-star, and then it is going to have the count, the number of times the customer has given 5-star, 4-star, right? So it should look something like the restaurant name, rating label, and then you have the rating count, right? So let's say restaurant name X, and this is going to be 5-star, and the number of times the restaurant has got 5 stars is, let's say, 10. And similarly for the other rows as well, right? So this is how it should look like. Now, how do you do an unpivot operation in Spark SQL? Yeah, so there is something called a lateral view stack. Yeah, and the way it works is basically it unpivots certain number of columns, right? So let's have a look at how does it do that. So we are first going to do a select star from this whole table, and the lateral view stack, let's first have a look at how it's going to look like, right? So we are going to say how many number of rows do I want per primary key, right? So the primary key over here is the restaurant ID itself. How many number of rows do I want per primary key? So I want 5 rows. Yeah. For rating 1, 2, 3, 4, 5, I want 5 rows. And how are they going to look like? They are going to look as follows. So it's going to be 5 star. And what is the value? The value is rating 5 count. Similarly, 4 star, rating 4 count, 3 star, and so on. Right. And I am going to name this as rating label and the rating count. So this is your rating label and this is your rating count. And let me select the restaurant name, and this is going to be your rating label and rating count. So per restaurant name, it is going to create 5 rating label and 5 rating counts, right? So let's go ahead and run this. Perfect. So you see that, let me sort it by restaurant. So you see per restaurant, it has created 5 rows, which is your 5, 4, 3, 2, 1, and then you have your rating count, and similarly for all of the others as well. Yeah. So let me rename this quickly as review count. Yeah. And let's create another chart over here. This chart is simply going to be your review count. The x-axis, the y-axis is going to be the label, and the x-axis is going to be the rating count. Yeah. Let's change the color and let's also put the labels. So this is going to be the rating on the y-axis itself, and this is going to be your number of reviews. Yeah. Let's also put a title for each of these. This is going to be your review sentiment trend, and this is going to be rating distribution. Yeah. So let me select this for a particular restaurant, and actually let me add the review trend, and this is going to be by restaurant name. What else? The review count should also be filtered by your restaurant name. Yeah. So if I select another one, this should change. Yeah. So you see that this has changed now. I select another one, this should also change. Okay, perfect. So now we have created this chart which shows us the rating distribution for a restaurant. Next up, we are going to perform issue categorization. So we are going to now list down how many different type of issues have a restaurant encountered when a user give them a review, right? And these could be your delivery issue, food quality issue, portion size issue, or a pricing issue. Yeah. So first we need to create a data set, and we are going to use fact reviews for this. And we've already seen earlier that we have categorized the issues over here, which is either it's a delivery issue, it's a food quality, pricing, or a portion size issue. Yeah. So let's join this with the dim restaurants table so that we are able to retrieve the name of the restaurant. And this is going to be our dot name as restaurant name, and then we start categorizing all of the issues, right? Count, distinct, case when, fr dot issue delivery equals true, then it should be my order ID which should be counted, then order ID else null and this is going to be count issue delivery, right? Let's do it for the other one. Food quality, the price, and finally the portion size. And we need to group this group by one, and let's see the result. Fr.issue price cannot be resolved. Okay, so let's quickly have a look at the column that we have.
issue pricing. This should be pricing and issue pricing. Issue portion size is correct. Issue food quality is correct. So let's run this. Okay, this works perfectly fine now. So we'll get back to our dashboard and let's put a few charts over here. This is going to be your delivery issue. Let's also rename this to issue summary, issue categorization instead of issue summary. Yeah. So we are going to use issue categorization over here. This is going to be a simple counter. The value is going to be count issue delivery. And again, this is also going to be filtered by the restaurant name. So we put it over here and let's put a title which says delivery issues, issue count. Similarly, we put it for the others, food quality issue. This one is going to be the portion size issue count. And then finally, this one is going to be the pricing issue. Yep, this looks fine. Now let's just get this arranged. Perfect. We have now placed all of the metrics which categorize issues, different issues here on the dashboard. Let's create the final two charts, which is the recent positive reviews and recent negative reviews. And for that, let's first create the data set for that. And we are going to use fact reviews. So fact reviews already has our review text, but what it doesn't have is the name of the restaurants. So that is why we are going to do a join over here, and we are going to simply put a where fr dot sentiment equals positive and fr dot review text is not null. So this is going to be r dot name as restaurant name, and this is going to be your review text and review timestamp. Yeah. And finally, let's order by the review timestamp descending, and let's run this. Okay, this looks good. And this is going to be your recent positive reviews. Yeah, let's duplicate this and create recent negative reviews, and we are just going to change this to negative, and let's run this. Okay, perfect. So we are going to create two tables over here. The first one is going to be recent positive, and let's also add this to the list of filters. This is going to be filtered by restaurant name. Let's also add for the negative reviews. This is also going to be filtered by restaurant name. So when I click this, I see that okay, all of them are filterable, and this one is going to be a simple table this time. In the table, we are going to have the review text, we are going to have the review timestamp, and let's just name this as reviews. Yeah, let's put the title as recent positive reviews, and let's also make this a little fancy by coloring this in green. Yeah, I'm going to replicate this, change this to recent negative. Yeah, this is going to be reviews. Let's change this to dark red, and let's also add the review timestamp. So we see the review timestamp over here, and we see the review timestamp over here as well, right? So now we have two production ready dashboards powered by our Lakehouse. The first one is
the chain performance insights, and the second one is your customer reviews, right? All built on the data platform that we created from scratch. Let's quickly publish this dashboard. So we are going to click publish, and here you go. So this is your final dashboard. So let's quickly recap what we built, right? Two data sources, Azure Event Hub for real-time streaming orders, and the other one, Azure SQL database for batch ingestion. Yeah. And then you have two ingestion methods. The first one, which is your Spark Declarative Pipelines for streaming, and LakeFlow Connect for batch mode. Yeah. And then we have a three-layer Medallion architecture over here, which is your bronze for raw data, silver for cleaned and enriched fact tables, and this is where we implement our data model. And one of the most interesting part is using AI powered analysis in fact reviews, where we deploy a model on Mosaic AI and basically feed in a prompt to understand the sentiment, the kind of issues that the customer has been facing, and basically categorizing issues into, let's say, pricing, portion size, or delivery, right? And then we had final gold for our aggregated business metrics, right? And powering all of this was your Unity catalog and Delta Lake for storing the data underneath, right? Unity catalog with proper naming convention of your schemas into landing, bronze, silver, and gold. All of this is orchestrated using workflows, right? So we've seen that we've used workflows for this part of the flow, where we ingest real-time orders and then process data from bronze, silver, and gold. And finally, using Databricks SQL for writing our queries, doing some kind of experiments, building the tables that we need for AI BI dashboard visualization. Yeah. So all of the code for this project is on GitHub, along with the sample data sets and explanations, diagrams, architecture. The link is in the description. 4K adapted to your use case, and let me know what you build from here, right? Share and tag me on LinkedIn if this project help you develop a real world understanding of how data engineering looks like and how working with Databricks looks like. I'm sure you're going to love other videos on my channel related to interview preparation, Spark performance tuning, Delta Lake, Databricks, right? So please don't forget to hit the like, share, and subscribe button and the bell icon on for more content. Drop a comment with what topic you would like me to cover next. Thank you for watching, and I will see you in the next video.